Hello, everyone. Are you ready for day 2 of Hot Chips? Hope you all got a good night's sleep. Went on late, as Hot Chips tends to do. And yeah, I slept all right, I guess. Today's going to be a longer day. 11 hours, start to finish, until 7 p.m. down here. And congrats to Janos, he passed his PhD Viva. If you're just clicking this video and watching the start, give congrats to Janos. Passing a PhD Viva is difficult. So today, in terms of Hot Chips, let's go over the talks we're going to have, because we're about half an hour before they're actually beginning. First topic here is machine learning. So we're going to have a talk from Groq, who have their tensor streaming processor. I believe that's what they call their TSP. That's a talk. It's going to be along the same lines as what we've seen from Groq before, but they might go into a bit more detail about how it works. You get plus 10 TechTechPotato points if you understand how this sodding architecture works, because I still don't understand it. Then we have Untether AI presenting their chip Boqueria, or Boqueria, however you want to pronounce it. 1,400 RISC-V cores doing inference. I got briefed on that. That's a pretty interesting chip. We have 2 talks from DOJO, going over some of the design, hardware, and architecture. Those, I've had a flick through the slides already. They're quite good. Last one of that session escapes me. I'm going to have to go look at the... Okay, Cerebras. Okay, we're going to have a look more into the core design of the Cerebras wafer scale. There's at least 2 really good slides for that. Then we have a 30-minute break, jumping into 3 talks about switches. First up is AMD /Xilinx, talking about a 400 gig Ethernet SuperNIC, SmartNIC, but they love to call it a SuperNIC. Then we have Juniper, the company who makes switches. They're going to be talking about a 28.8 let me get this right. Juniper's Express 5, a 28.8 terabits per second network switch. Oh, excuse me. Routing ASIC plus variations. They've got 4 different ASICs to present, essentially, in that family. That's going to be interesting, because we rarely hear anything from Juniper, and it's very nice to go under the hood with some of those categories. NVLink is the third topic of the section. So we're going to go into NVLink4, the one paired with Hopper, see how that's different from previous generations. Then we have a 1-hour lunch. Hope you all got some good lunches, or in my case, dinners planned. And then we move straight onto the Tesla keynote. So this is Tesla's 3rd talk of the day. This is going to be... I've seen they've actually got 87 slides they're planning to go through in an hour. They probably won't be able to go through all of them. It's going to be a very dense topic. So we'll see what we can do after the event with regards to video, to everything for Tesla. Then we have a 1.5-hour session, 3 talks. That's basically ADAS and Grace, so autonomous driving and Grace. So we've got a talk on Orin, NVIDIA's Orin. We've got a talk from NODAR about their self-driving technology. I believe it's self-driving. Let me just double check. Oh, it's starting to talk. Ready to sneeze. NODAR 3D vision system for autonomous vehicles. And then the third talk is NVIDIA's Grace. So we've got some architecture details on NVIDIA's Grace. Some of that's already been made public. So if you haven't seen that already, we get to go through it at Hot Chips. Then we have a final 30-minute break, and then 4 talks in the mobile and edge section. This includes AMD talking about Rembrandt, Ryzen 6000, the mobile processor. Then we have Meteor Lake and Arrow Lake. So if you really want to wait for that talk, that's 5:30 p.m. Pacific. So Meteor Lake, Arrow Lake, and we'll see a little bit of Lunar Lake. Then we have Mediatek with the Dimensity 9000. And then the final talk is Intel Xeon D, the newest generation Xeon D. That's their edge processor. So a strong number of talks, 5, 8, 11, 15 talks, plus the keynote. So we're going to go a bit longer than yesterday. Kudos to everybody who stuck around yesterday, or if you popped in and popped out. We got some reasonably good numbers. I was comparing the numbers to last year. So last year, day one, we had 360 peak attendees and about 900 hours watched. Yesterday, we only had 180 peak attendees, but about 860 hours watched. So fewer people came at the peak times, but everybody seemed to watch for longer. I think yesterday wasn't as jam-packed as it is going to be today. Yesterday, the talk from Light Matter I really liked. Intel Keynote, yeah. So, if you all want the slides, not the slides, sorry, my notes from yesterday, there are 56 pages. It's linked to in the top of the live stream from yesterday. Go click through there and you can find a Google Docs copy. I'll make the notes from today available afterwards as well. And yeah, that's likely going to go beyond 56 pages. So hope you're ready. And welcome to everybody coming into the stream. It's Carl and Flash Photo from yesterday. How you doing? And Warren as well. You'll see, Warren, I've given you admin status. Yesterday there was a lot of bots. And they all wanted the same thing. So it's interesting to see how many people are pre-recording their talks today versus giving them live. It's I need to go into the Slack actually and ask the dojo people if I can get an invite to the AI day, which is coming up soon. So hey Don, hey Will. So today I've actually prepared properly. Instead of bubble tea, I've got coffee. And instead of hot chips today, you'll see me munching through some watermelon instead. Because I need to eat some fruit this time. But yeah, for those of you who are signed up to Hot Chips, the slides are now all up. I think there were some problems with the Orin slides that may or may not be fixed. Apparently it's in the global download if you want 300 megs of slides. Yeah, but going through the Tesla slides is going to be a fair-paced affair. It's going to be tough. Yesterday I shared about 2 slides per talk. Today I'm upping that to 3 because I felt like there were, aside from the title slide, you really need at least 2 more. Question from Batuza: can I now watch it anywhere? You can only watch it if you're signed up to the conference. It's a paywall conference, so there is a paywall fee. Right now it's $160 if you'd like to attend. If you want to watch the talks afterwards, they generally get posted in December. So everybody who signs up gets 3 months access, essentially, to the replays and all the slides. Then they get posted online in December. Or you stay tuned to some of the content that's coming out from the press, from the analysts, from the show. So it's because they do have to cover costs. There was a lot of talk yesterday about being in person for next year. I'm looking forward to that. Though in person, I was doing live blogs when I was at Anantech. If I'm doing live streams now, it's a little bit different. So we'll have to see what I can do with a live stream. If we can organize something at the event. I'm actually speaking to some of the organizers at Hot Chips, so we may get a special dedicated TechTechPotato studio to do the watch stream. Again, you'll still have to be signed up to watch it virtually at least. And then if I can get also another host on, we can go in and out and perhaps fill the breaks, fill those breaks, fill the lunches with interviews in case you want to stay during the break, so we just don't have an hour of dead time. So Hot Chips is a 3-day event. Day 0 on the Sunday are tutorials. Then day 1 and day 2, which both go from about 8:39 to about 6 or 7. So they're long days if you want to listen to every talk. When I was there on site, I didn't used to live blog every talk. Partly because some of the academic ones make me want to go to sleep. And sometimes they do get speakers in who are so monotonous it's not worth... it's the topic may be interesting, but it's absolutely the wrong speaker for it. So we'll see what we can do on site. If it's something that we have to plan, I mean, I don't imagine being able to cart a streaming PC over there, because right now I'm using 2 monitors plus this laptop in front of me, and it's kind of not enough, especially if I want to keep on track of the Slack as well. So, but we've got still about 20 minutes before we start, so make sure you've got drinks and food and stuff. It's the bone apple tea. Watermelon is good. I hope the audio is coming through fine. I know we had some small problems yesterday, but it should be sorted now. I've actually got 2 fans on me, and it doesn't look like it's being picked up from the microphone. And no crackling. Dom. Here's one that'll be interesting for everybody to answer to. University applications soon. Would you recommend I do physics or electrical engineering? I would suggest you do electrical engineering. My suggestion now for anybody doing a STEM subject is make sure that your subject includes the word engineering, regardless. Don't do computer science, do computer engineering. Don't do chemistry, do chemical engineering. They don't do physical engineering. So, yeah, it's raw, pure physics can be fun, and I know people who successfully navigate that route. But electrical engineering, the world needs more electrical engineers. Right now, the US is having a problem where so many students are doing computer science. They're doing software-focused degrees rather than hardware-focused degrees. It used to be that most were E's and there was only a few CS's. And that graph has kind of switched back over the years. So now the US is a software powerhouse rather than a hardware powerhouse, whereas Taiwan and Korea, and to a certain extent Japan as well, they're more hardware focused than software focused. And don't get me wrong, you do still need software engineers, but I'm assuming you're based in the US, if the US wants to be more independent on its computing, you have to have electrical engineers to do that work. Even if machine learning comes and takes 85% of the jobs, you still need electrical engineers who know what they're doing. So I didn't do electrical engineering. I had the opportunity to do a GCSE in electronics when I was at high school during my 6th form, and rather than that, I went into I stayed in the cadet force for another year, which was a big error on my part. So instead, I had to be a drill sergeant in a cadet force. So, or every Thursday afternoon at least, anyway. MS, aren't you better off as a software engineer as you have a better market? I mean, yeah. Though Dom did ask between physics or electrical engineering. So, yeah, pick the one with engineering. Hi, Arik. How you doing? So Pat's got an interesting point. Don't think you can study EE if you're colorblind, which a lot of people are. So I am kind of red-green colorblind. It doesn't come up day to day. However, if you give me the Ishihara tests, which are the spots with the numbers on, you're meant to get something like 30 out of 33. I score 13. So it doesn't affect me day to day. And I have done some pilot training and it wasn't an issue. So the weird thing about university is people say you need all this extracurricular stuff to get accepted, and they want people with good character, but the minute you're in, nobody gives a sod. Once you're in, nobody cares what extracurricular stuff you... Excuse me. What you do. It's... Yeah. I mean, everybody likes having a good portfolio. Having stuff that they can refer to, whether that's GitHub repositories, examples of design, if you've been featured in the media, just simply if you wrote a blog post about your final year project, you can say, published online, that sort of thing. So that sort of stuff. Mark, I hope so. I hope so for two reasons. One, it'd be great if Hamilton could keep his record of winning a race in every year he's been in F1. Or two, I just want to see George win. George deserves a win. He should have had Sakir. But he should have had Sakir like Ferrari should have won 3 races this year, though. So, yeah. Is it Belgium this weekend? I think I got a message saying it was Belgium this weekend. Back to it in Spa-Francorchamps. Though that being said, they are complaining that Spa's been a bit of a procession over recent years. So, Spa doesn't even have a contract for next year. For people who don't follow F1, this will just be, whatever, people talking sports ball. But Spa in general is a nice track, at least on the driving games. So there are some buttons here that I didn't realize existed in Studio. Stream markers. So is the audio buzzing? Or is it buzzing when I'm not talking for a while? Because I think for some reason it amplifies the gain if I don't speak a while. How about now? Morning, Schmarv. Audio is such a pain. I've already got equivalent of RTX voice on, so yeah. Okay, that's because I have a fan here. I don't have I have also a fan under my legs, but you don't seem to be able to hear that, so. Okay, cool. It's just the fan on my desk. Yeah, Teresa's asking a question about the Intel Trinity. I saw something in chat about that. I don't know what people are talking about. So, yeah, Janus. Okay, so it's not RTX voice, it's OBS's RNN voice. It's the high CPU version, which is meant to be high quality, so yeah, I think once we move to more in person, they might make the student tickets cheaper. So we'll see. I mean, if there's enough people, so I did a poll at the end of yesterday, and people did list the price as one of the reasons why they couldn't attend. I think about 17 to 20% of people said price. So yeah. We're still just we're about 10 minutes away from starting. I've got the stream in front of me here, so it's just going through the motions of showing all the sponsors, but nothing's actually started yet. Arik, is there any goal towards optical CPU? No. But there is goal towards optical interconnect. Integrated optical interconnect. Integrated silicon photonics. We had 2 talks on it yesterday. I'm pretty sure probably next year or the year after, we're probably going to have a silicon photonics session, because there are now enough companies in the industry with silicon photonics using Global Foundries silicon photonics process that we should have an optics session, or at least the committee should be inviting groups of optic companies to present at Hot Chips. So to be honest, if you're a student, it might be worth asking if there is a bursary scheme or a scholarship scheme to attend conferences. Most medium to large size institutions probably has a scheme. You might be only able to reclaim $30 or $50, and it's there, just nobody uses it year on year, and it's something you have to ask for. So it's simply a case of asking if there's a conference I want to attend that will help me with my studies. Is there a scheme in place where I can recoup some of the costs in the form of a bursary or a scholarship? And there may be some requirements to that money. It may be we'd like you to write an overview of the event for something online. And to be honest, most of these places will be happy if you're strapped to 250 words put together. You know, my experience at Hot Chips, and at the end you say, would I do it again? You betcha. There's like 2 weeks worth of stuff here to go through, whatever. That may happen, or you might find a professor who kindly pays for it out of his pocket. So even if you're not doing anything computer related, just say it's to do with sustainability or something, because some of these talks are. Swatson, Tachyon does not have a presentation again this year. However, there will be something going up on the channel and Chips and Cheese later this week. It's something I've been doing in collaboration with those guys. So yeah, it's there will be something coming along. Johto, you know about MZIs? MZIs can do compute, but the problem is it's still not dense enough. So Anastasia is in chat. How's it going? What? I was going to say, what time is it? Shouldn't you be at work? But I guess you're a couple of hours ahead of me. So, morning, Darrell. Morning, Amarvia. Are you the Amarvia in the Slack who's asking questions from Cambridge? Just want to check. Shmarv makes a good point. Some companies will sponsor trips. If you don't know how to get in contact with a company who can sponsor a trip, email the event. The event will have something like registration@hotchips.org or whatever, and say, look, I'm a student, I'm interested in coming, I'd like a company to sponsor the trip for me. Is there anyone you can direct me to help with that? And chances are they will either say, yeah, we do this all the time. Here's some contacts, or nope, never done it before, don't know what you're talking about. It's worth an email. The worst they can say is no. So, oh, okay, you are the Marvia from Cambridge in the Slack. Good to know. Good to know. I did see some of your questions as I was scrolling through it last night after the stream, because I can't monitor Slack while I'm doing this live stream. So, Anastasia, are you actually signed up to the conference? Did you get a press pass? Please tell me you got a press pass. Otherwise, I need to have some words with Ralph. If Ralph's here. So. Yeah. Amarvis says if you mention that you've been to events, to recruiters, and they'll say what were the events like, who presented, and you can rattle off a few names or something that you learned. Perfect. So, yeah. Today, Anastasia, today's the day definitely to watch. Yes, today was a bit hit and miss. Which is weird. Usually day one's the day to go to, but they usually have something at the end of day two to stay for, and this year it's, Meteor Lake. So, Meteor Lake, Arrow Lake. So, Warren, drop a link to Anastasia's channel. This is the point where I ask whether it's Anastasia or Anastasia, because my wife pronounces it the latter. So, should be about a minute from starting, though they have been starting late. So we'll see if they're ready. So again, this session, Groq, Untether, Tesla, Cerebras. So Dennis at Groq, Robert Untether, Emil at Tesla, and Sean at Cerebras. So I think I've heard of the name Greg Yerrick. I can't pull his face out of my head, but I'm pretty sure I've heard the name. Johto, yeah, €9 ticket to ISC. Yeah, I've never been to ISC because ISC always falls on my wedding anniversary. So I'm usually booked that weekend. If it had moved, then yeah, I'd be there. So. Okay, we should have started by now. It's Gustavo. It's an Eastern European thing. Okay, this is day 2. And again, I'll share my notes after the event. They'll be on the video, this video on the channel, or I'll post them on my Twitter. So we'll do that after. I mean, at this point, I can probably get 1 or 2 2 or 3 passes to an event. As long as people agree to be my camera people. Because for them, press passes are such a minor thing to give out. So okay, here we go. 2 minutes late, and we're starting. The thing with the chips and cheese people is some of them are still in studying, so talk 1 is Groq TSP. Seeds. Pre-recorded. So here's what it is. We go tensor stream multiprocessor. Again, if you understand this architecture, good for you. Because I have learned about it several times and I still can't wrap my head around it. Still a startup, Groq. Been around 4 or 5 years. So we're going to go software-defined hardware and deterministic throughput. The big thing about the TSP is that the latency is consistent. Amarvir, the best way I can describe it is the data doesn't move, the instructions do. So, yeah. Okay, these slides are really dense. This chip is best for batch 1. So... So I've changed the slides. We're not up to it yet, but we're going through. So excuse me. Yeah, load balance without adaptive networking. Okay. So functionally sliced microarchitecture. So SIMD functional units. If you want to understand what the architecture looks like on that slide up there, a regular core is on the left, Groq is on the right. So they've split the pipeline horizontally. So basically you have execution ports horizontally across the chip. So they're only talking about integer 8 to 32-bit accumulate. This is what they focus on. It's just an int 8. Then we go to this slide. So 80 terabytes sec of bandwidth on the chip. I'm pretty sure I could understand Groq, but I would need somebody to literally take me through it and be prepared to spend 8 hours to go through it, answering all my questions, so I understand what bits are transferred where. Enigma, yes, that's 5:30 p.m. Pacific. That's when Intel. I should perhaps put a sign up saying Intel at 5:30 p.m. because that's what I'm getting most questions on recently. So, instruction flow up and down, data flow left and right. No dynamic hardware caching. All compiler controlled. Fully pipelined 144 wide VLIW. One instruction issued per cycle at each dispatch path. Functional units in lockstep. It's going to be Meteor Lake and Arrow Lake, and there are some slides talking about Lunar Lake. So I'm not a fan of software-defined programming because so far it's failed a lot. So instruction set, the domain instruction set. So you have to use their libraries, essentially. You have to use their optimized version of TensorFlow compiler, jobby, whatever. So yeah, not BF. So all the standard integer and floats. So yeah, if anyone from Groq is watching, where are you based? Yeah, just invite the press over just to a Groq day. It's like, we will make you understand our stuff. So again, if anybody wonders what I'm eating, it's just the complete opposite of hot chips. It's watermelon. Yeah, everybody's based in SF, aren't they? It's just a case of whether that's the main office. I'm going to be in the Bay Area end of September, so I've been through Miami once. Through it. Didn't get out the airport, but I've been through it. Is it 88 in independent mem slices? 220 mem SRAM total. So yeah. Packaging drives topology. Okay, so they're calling it the Groq chip. How many chips on a card? I missed. Is it 6? And then it's 12 or something. Not node, rack. That's how it works. Who's the host? I mean, to be honest, the thing about Groq is, hang on, right. So AMD once trademarked Groq, Grok, and I argued with, I think it was Hassan from WCCF, basically saying, no, that's not a product name. That's just them trademarking something to take people off the scent. And he was insistent. He was, no, 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 no. This is definitely going to be an AMD product. An AMD product. Why would they? Yeah. And AMD has since allowed that trademark to expire. And I told him it's because that to grok is a common computing term, as in to understand. And he was like, well, I've never heard that before. So he didn't believe me. He was so adamant and so strong-headed about it. And I was like, no, no, and yeah, so whenever I hear Grok, I remind myself of that conversation. That was when WCCF was worse than it is today. All the seeds. Yeah, Mountain View. It's yeah. I'm in the area for Intel innovation, so spend a day with another client, and I think I've got another day spare. Depends what I actually want to spend time working rather than being in meetings. So. In the talk, they're talking about ISA. So, it's 7 nanometer Enigma. Johto, I'm only sharing about 2 or 3 slides per talk. It's with the previous live blogs being pretty much all the slides. That didn't go down too well with the committee, so I'm providing a balance. So, aren't you signed up to Intel's event, Warren? Ping me over Discord, we'll sort something out. I mean, Grok's also been the name of like goblins in dungeon crawlers and stuff. You work in Toronto. Have you told me who you work for? I mean, yeah, I'll be in. So Justin, storage is in my wheelhouse because I have ideas for projects involving storage, which would be fun to do. I just can't get anybody to commit to doing enough of it. So yeah, I do like a bit of storage. Question is, Which storage do you work for? Which storage company do you work for? Morning, Gaurav, or afternoon, depending on where you are. They're talking about, two CPUs to 8 TSPs. But they don't say who the CPUs are. Oh, yeah. Company name like Pure Storage. Yeah. So. That is a real yellow slide with these pre-recorded talks. Real scale. That's a TM. Chip to chip links and flow control. I have the alt code for trademark memorized. Hold down alt and on your keypad press 0153. And yeah, 0186 is degrees. Just the last 2 digits up one, so. See, on chip. I can't use a 10 keyless keyboard. I need to have my keypad because that's where I do 90% of my numbers. It's just I prefer just doing it with the one hand. So oh, this is so if you have a chip where your result finishes every time in, say, 12 microseconds. If you're in design and validation and the chip doesn't finish in 12 microseconds, you know something's wrong. So. Oh, is that the code for pound sign? So you see, because some of my keyboards are US and some of my keyboards are UK, I just install both in the operating system and hold Alt and Shift to select between them, because American keyboards don't have the long Enter key, and the forward and backward slashes are weird, and they don't have the pound sign. And unfortunately, I just end up with some American keyboards. So. So. Now they're using Google's paper on mercurial cores to validate their ASIC verification. They taped out this chip before that paper came out, though. That's really weird. With the memory and compute or compute in memory, Yeah, Untether's going to talk about that the next talk, because that's along those lines. But yeah, me and Sally from EU Times was having a conversation about this because people, they're different, but people keep getting confused, and other companies have got marketing names for them. So, Mark, you mean the hashtag? Hashtag. You know, so I'm an influencer. Now they're talking about doing some maths. Cholsky decomposition. Or all reduce. Basically saying they can maximize utility of the chip, though you're not using all the multiply accumulators at the same time. So yeah, it's weird. It's weird how they're doing their it's weird how you do monitor, uptime and the time that useful work is doing. So what's the alt code for an interrobang? Interrobang. Pretty sure that's my favorite piece of punctuation. Yeah, somebody's going to ask about ML perf numbers in the Slack. Betcha. Getting to the end of this first talk now. To be honest, ML perf numbers don't tell the whole story anyway, Gaurav. It's very specific and...
What's your minimum specification?
I think I have those presentations saved somewhere, Joto, if it's VLSI 2022. But yeah. Okay, now it's time for Q&A on the Groq session. So it's deterministic when everything's on the chip. If anything's off the chip, it could be non-deterministic. Gotcha. So yeah, if everything fits in your caches, you're fine. That's a stupid answer. Yeah, we don't submit MLPerf results because we haven't found a benchmark in which we're better than NVIDIA. Basically, he's talking about systolic execution. Prove me wrong. Data flow is just essentially systolic compute. I mean, come on, call a spade a spade. Okay, end of Q&A. Next talk is Untether. It's not from Boqueria. That's NVIDIA throwing shade. Robin's good fun. Had a really good chat with him the other day. He said I was a very easy person to brief because I understood it. And because I asked relevant questions. Rather than look dumb. Because I'm the sort of person to ask loads of questions, I can't imagine being in a briefing where people don't ask anything. Or they don't understand it after 2 minutes and just let you talk and talk and talk and talk. So... I technically have headlines, I just haven't identified them as such. So, I mean, yeah. And again, this is another pre-recorded yellow presentation. I mean, Groq has an interesting architecture for, you know, deterministic for batch 1 stuff. Yeah, okay. Night Prasada, we'll be here. Come back in 10 hours, we'll be here. Yeah, they went through a bit I'm going to have to bring up the slides on my end just so I can capture some of this stuff. So let's see. Boqueria, okay. There we go. So the point here is this is inference focused. FP8 is key to the design. So their argument here is recommendation engines, such as Amazon, Baidu, whatever, 1% less accuracy equals millions of sales lost. So you need to be as accurate as possible. So this is where FP8 comes in. So meets memory requirements. I've never heard of green array JOTO. So, yeah. FP32 equals 100%. BF16 equals 100%. FP8 equals 99.6% accuracy. So, again, inference. So, at memory compute. I've put up the slide of what the chip looks like up here. We'll get to it in a couple of slides, though. These data types are, at least when it was explained to me, it was easier to understand. So right now he's going through different types of in-memory compute, analog versus systolic. And I mean, it's a video. It's a video you need to make about in-memory, at memory, computer memory, processing in memory, near memory. So, and then, the stuff that Samsung's doing. So basically what they're saying here is that their arithmetic units are right next to their SRAM. Okay, so now we're going on to the slide that's on my screen. 158 RISC-V cores, 1.35 gigahertz, 1008 BFlow 16 tops, 2015 FP8 tops, 1 petabyte per sec SRAM bandwidth, 32 GB LPDDR5 across 2 x64 64-bit ports, 819 gigabit per sec DRAM bandwidth, PCIe 5.0 x16 for Connect, 3 times 5.0 x8 for chip to chip, int4 to BF16 supported. Each bank has 328 kilobytes SRAM with 512 processing elements. Each two RISC processors controls 4 row controllers in a memory bank. Do I have this slide? No. And yeah, what you end up with is 64 SIMD processing elements per row. Somebody do the math on processing elements. So you have 64 PEs times by 8 rows per 2 risk 5. There's 1458 risk 5. So 64 times 8 times that equals processing elements. So 373, yeah, 1,248 processing elements total. Each processing element has how big's the SRAM array? 640 bytes SRAM at 0.4 volts. So if we go to our favorite Wolfram Alpha, equals 238.9 megabytes of SRAM total. So there we go. If you bring the math out, it works to what they said the amount of memory they had. So yeah, 238 megabytes of SRAM. That's so. So yeah. Per 2 risk 5 cores, there are 8 rows of 64 PEs. Over 1458 risk 5 cores, that's 373,248 PEs. Each PE has 604 bytes of SRAM. 373 times 248 times 640 bytes equals 238.9 megabyte SRAM. Yep. Special registers for soft max layer norm sparsity 0 detect, e.g. 0 times 0 plus 0 is bypassed, saves power. The amount of hardware that does 0 times 0 plus 0 calculations and burns power is insane. And some architectures count that as multiple operations as well. So here we go into data paths. So FP8 designed for inference. So for training, FP8, that's sine 1, exponent 5, mantissa 2 for range. FP8, S1, E4, M3 for precision. For inference, this is a slide that's on the screen right now. FP8, S1, E4, M3 for range. FP8, S1, E3, M4 for precision. within 1.2% accuracy of bfloat 16. Yeah, so standard RISC-V cores, but they're the 32-bit EMC instruction set, 20 plus custom added instructions. Nile, yeah, they said it was 1.35 gigahertz, I think. But yeah, that sounds about right. So each RISC-V core has 6 kilobyte memory, 32-bit ALU, 32-bit multiplier, scene register file, 4 threads. So I don't have this picture, but there's a ring knock around all the processing elements. Yeah, I'll show up that slide. That's 1 sec ring in each direction. 5 terabyte sec east to west, 1.9 terabyte sec north to south. That's just because of how the chip's designed. 4 megabyte scratch pad for data manipulation. 32 gigabytes of external LPDDR5 with is it 109.6 gigabyte per sec bandwidth. It's yeah, 128-bit. So the knock is a ring. So the I/O ring around the outside, the I/O around the outside, the knock around the outside is a ring. Then each row or column, as you can see in the slide, is its own knock itself. So the chip. So each row has 30. Hang on. 30 banks, and there are 219 columns. It's 219 times 30. 6570. Yeah, it's a bit weird. I don't know. Scalable architecture can reduce number of memory banks. Scale from 1 watt to tens of watts. A series of cards from M.2 to PCIe. So down to B1, B2, B3, B4. Today is B4. PCIe card, 6 of these onto a single PCIe. That's 1.4 gigabyte SRAM, 12 petaflop of petaop of FP8, and a total of 129 LPDDR5. That's 32 times 6. PCIe 5.0 X8 chip to chip. And it's a standard 2D array of chips. So, and because it's all PCIe, yeah. So, this SDK is called ImAI Gin, as in Imagine SDK Tool Flow. Model garden of pre-created neural networks. Most customers have their own. And, you know, it's kernel libraries and all the other features to do with software optimization. PCIe card is called the Tsunami. It didn't hit as hard as I had the briefing, but those are some terrible names. Stop trying to fit AI into the name of your company. Please. Please. Yeah. Should be 5. So, are we saying that Super Monkey Ball, the main character, is called AI? Yeah? Oh. Don't you all start. Jesus Christ. The highlights of last year's spa race is going to be 2 minutes, 2 laps anyway. So they're doing efficiency throughput on certain networks, but they're working off of theoretical max performance. So Boqueria 2 Peter Ops FP8 at 30 teraops per watt inference accelerator. So that's per PCIe card, isn't it? Yeah, okay. And then 30. Okay, ML perf. Question's been okay so far. Somebody's computer is popping up with messages on the stream. Is it just me? Haha, I got it right. Haha. Meteor Lake's at 5:30 p.m. Pacific. So you got a fair few hours, yeah. It's about 8 hours, in 8 hours' time. Yeah. Media have got the habit now of just posting the slides when available, rather than waiting for the talks. It's the end of Q&A. Time for Tesla. Depends if you think that WCCF is gonna provide a fair and balanced analysis of the slides. So oh, and he's Romanian. Or at least he studied in Romania. Buna Emil, ce faci? He's not here in the chat, but whatever.
What's your minimum specification?
There's some custom silicon in it. Oh, is this a? This thing. This might be a live presentation. Okay. Distributed. No, I can't type. System. CPU to die to module to board to rack to cabinet to system. Integration gets looser as you move up. Lower bandwidth, higher latency. Yes, we know. All about compute, comms, synchronization. This talk has a lot of slides to go through, so I hope he's gonna speed up. Okay. Micro arch of DOJO node. Yeah. I didn't provide this slide, did I? No. I thought about this one, but it's yeah. Looks like a CPU. 1.25 RAM per core. Dedicated CPU, local mem, comms interface, NOC router. 32-byte fetch window. Holding 8 instructions. 8-way decode with 2 threads cycle. 4-wide scalar scheduler. 4-way SMT to int ALUs, 2 AGUs, register file replicated per thread, 2 wide vector, 4-way SMT, 64-byte wide SIMD, 8x8x4 mat mul unit. SMT support focuses on single app with multiple threads. No virtual memory, limited protection mechanisms, software managed sharing of resources. Typical kernel uses 1-2 compute threads and 1-2 com threads. So 1.25 SRAM per node, 400 set load to 70. Store 8 byte 16 byte granularity. Load, store, load plus issue from local memory. Explicit transfer instructions for remote memory access. List passing. And 64 bytes to and from NOC router per core. NOC to NOC is 128 byte each direction. I forget whether bidirectional connection is anyway. Yeah. 2D mesh across all processing nodes. 8 packets per cycle across node boundary. Each node has independent network connection, direct SRAM comms, 1 read, 1 write per cycle, single cycle per hop in every direction. Block level DMA for data push pull. Pipeline funnel. 8-way decode, 4-way int, 2-way vector. So 6-way basically. Simple primitives can execute early in decode. Looping, list parsing, predication. Scalar instructions, regular integer code, AGU, network sync, primitive, forgive my spelling, primitives, vector, data path, 8x8 mat mul, 64-byte SIMD. I'm going to have to pull up the slides because they that's the wrong slide deck. Yeah. Is it? They've done the talks in the wrong order. Okay. Yeah. This is the microarchitecture. The talks have been put in the wrong order on the website, so okay. Special ML formats. So CFP8, storage CFP16, special ML instructions. So Justin, there's a lot more ML formats. So okay. Formats BFP16. 8 bits. Is that exponent? 7 mantissa. Is it FP32? 23 mantissa. P16 is 5E10M. So CFP is 4 bits exponent, 3 bits mantissa. Bias 6 bits. So the BIOS essentially moves the range. So they also have a. So they have 5E2M, BIOS 6 bits. CFP 60, 5E10M, BIOS 6 bits. Up to 16 data types can be used at any time. Each 64-byte packet sharing a single type. Yeah, it looks like a totally custom ISO. I think it's just to take control of all the data formats. I mean, with that CFP8 at a 5-bit, 2-bit, the idea is that they can showcase anything from -2 to the 32 to -2 to the -62, and then the same. Spatial. So now we're on the slides that's on my stream. Mm-hmm. So the full tile is what we've seen before. The 5x5 array of D1 chips, because each chip is T1. 5 sec off tile bandwidth per edge. 15 kilowatt power. Full DOJO system is multiple training tiles. That's each 15 kilowatt. 2D array. Each training tile 11 of SRAM, 160 GB shared DRAM. So shared memory support. Private. So the point is you take one chip and you have 25 chips per tile and you put multiple tiles together. So yeah. Oh, yeah. Tesla has its own transport protocol. Yeah. Yeah. Bandwidth is worse the further you get. Okay. So Johto, I believe the scheduling is done externally by the control processor, which is coming up either this talk or next talk. Like I say, they're doing the talks out of order, so who knows? Software has to optimize for the architecture. So, yeah. Right. Oh. Uh, the annoying thing is that it would make much more sense if we were able to see what happens step to step. Show us in a diagram, an architectural diagram. There's about 6 more slides in this talk. So this slide, when it goes down, why does it go down 3 elements rather than just to the first one on the edge? That's slide 23, slide 24. That's weird. Slide 24 or slide 25. The routing goes down 3 elements and across rather than down to the first one and across. So it's just talking about communications from chip to chip. semaphore counting in hardware. Freeze. A lot of people complained to Hot Chips last year because Tesla announced Dojo a week before Hot Chips, and people were complaining, well, if Hot Chips is the right event, why didn't they reach out to get Tesla be part of the event? If nothing at Hot Chips is as good as Tesla announced. So this is why Tesla has 2 talks plus a keynote today. Yeah, okay. Yep. I wonder if there's going to be any questions and whether we'll just go straight into the next talk. So de-emphasized poor scaling mechanisms like virtual memory coherency. DOJO relies less on local storage and more on data movement, bearing in mind that data movement is expensive energy-wise, order of magnitude higher interconnect bandwidth than typical distributed systems. Point is, if it's 3 petajoules per bit and you need to send a petabit, you're consuming power. So a video with lots and lots and lots of questions. I don't think we know anything about clock frequency, Johto. You got to assume that given that it's a 14 kilowatt system, you're running at 0.7 volts and 20,000 amps. So you're probably a gigahertz or around, maybe less. Hot chips, the most expensive ticket right now is $160 for virtual. For in-person, it's going to be a bit more. Next talk. So I need to go back through my slides because either they're in the wrong order or no, they're just online in the wrong order. Okay. They're going to be talking about disaggregation between compute memory and I/O in this talk, so it is what it is. Yeah, disaggregated compute, disaggregated memory, disaggregated I/O, and we're going to go through each of them. So, starting with compute. So that's the tile. So the idea is that if you have a tile with 25 compute dies, even though you start with known good dies, you may package one of the D1 dies incorrectly. You can disable it and just route around it and still use the rest of the tile without binning it all. So that's the thing. I mean, you might end up putting that tile at the edge of your network, but it is what it is. A flop is a 64-bit compute. BF16 is not a traditional flop. Call it an op. I don't care the FLs in it. Now we're on the memory. So it's the V1 DOJO interface processor. Now this is going to be interesting. This is the version 1. So DIP is a DOJO interface processor. Now IO TTP/OE point to point over Ethernet. High radix JOTO for 8-channel, yeah, that's right. 209.6, I think, or something along those lines. So rather than go from chip to chip to chip, you can just go across the Ethernet network. Yeah, I don't think I have a picture of this, no. But, yeah. JOTO, yeah. Basically, each switch is connected to up to 30 tiles. So you just go through the switch. This is the second DOJO talk right now, so now we have DOJO interface card. Are they going to show a picture of the NIC? No? No picture of the NIC. So you have the DNIC, the DIP. Everything that starts with D is DOJO. So now we have the training matrix. You can see the slide on the stream. They've got a picture of the network interface, Justin, what it is now. So there's no security on this because it's just for internal. So now we're talking about model execution. That's probably a control port, IPMI, Justin. Hmm. Yeah, by security, I'm talking about partitioning for multi-user stuff, that sort of thing. Yeah, you got ECC and some RAS and stuff like that for sure. Nathan, they said they have silicon. They wouldn't say what state it's in though. I wonder if we can get high resolution images. Those of you who are in the Slack, can you ask in the Tesla chat if we can get high resolution images of the PCIe cards? Or higher resolution images that we can share in stories and talk about in podcasts? It would be nice. I'm not at my Slack right now, so... This is 45 slides. Last one was 27. So we're currently on slide 33, and he's got 10 minutes left. So... Oh yeah, you're right, Justin. And zoom into 200%. You can tell it's a those PCIe cards. They're renders. They're not real. So it's a PCIe switch in the middle though. You know, notice it has two 8-pin PCIe connectors. So all the DRAM, when they say it's DRAM, it's actually HBM. So yeah, that deserves going through in a bit more. You think it's CPS 12 volt? Some data center cards, not all. All the NVIDIA cards, they're all PCIe, aren't they? Do I have any more slides now? So they're probably doing silicon bring up the Red Dog just to see whether it works and what frequency they can run it at and what yields were. Because you've got the known good die, and then you got to package it and make sure it yields for the packaging, and then you've got the 15 kilowatt system, which needs to be cooled, and you need to make sure that works, and then you have to test the silicon. So yeah, Nathan, the fact is somebody asked in the last talk and they said less about the state of the silicon today than they did last year. That's sometimes worrying. Oh no, sorry, Justin, you are right. The DIPs do have Ethernet TTPoE connections to the switch, but the DNICs are attached to the CPUs. Right. Okay. No, you're right. Hey Nathan, can you get me an invite to AI Day 2? And okay, that's the last slide. It's just talking about disaggregation. So Q&A, and then last talk of the session, which is Cerebras. Hmm. I think they probably see a drop off in performance at 120 tiles. 3 wide tiles. Is that because you have 3 wide? You can only fit 3 in a rack. So 30th September, guess who's going to be in the Bay Area? I can please invite. So final talk is Cerebras. We're actually going to get the architecture. I didn't get a briefing on this. It's annoying, but it is what it is. I think Cerebras now have 20, 25 plus customers. So and a big up to it's probably Rebecca Lewington that recorded and edited these. So shout out to her. Oh. Yeah, Justin, I will. I don't have Slack on my setup right now, so I'll do it. If everybody can give a thumbs up when I ask for an invite to AI Day. Maybe I'll get a response. Oh, excuse me. It's not carrot, it's watermelon. So Sean's been doing these talks for a few years now. The first one was that I saw was a bit hit and miss, but yeah. And here we have Cerebras' core design. 228 by 170 micron core area, TSMC N7, 5050 logic to decay logic, standard cells, high density SRAM per core. So 800,000 cores at 30 milliwatt per core, 1.1 gigahertz. Ask what voltage it's at. Yes, we go. So this is basically memory at compute. So all SRAM is single cycle access, full data path perf without caching. So so 48 kilobyte, that's 8 banks, 6 kilobyte per bank, 32-bit wide each single port, full 2 full reads plus full write per cycle. Yeah. So 200x normalized memory bandwidth per GPU. So full perf out of SRAM across all LAS levels. So GPU limited to Gem V, Cerebras can do gem v dot vector vector and vector scalar multiply. Sparse gem is 1 AXP per non-zero weight. Sparse gem is just XP operations, so need 3 byte flop for XP. So each core is fully programmable. 16 general purpose registers, compact 6-stage pipeline. Okay, it filters out the zeros. Yep. Filter 0 data at sender. Only non-zero data sent. That's good. Yes. Okay, so here are the big numbers. 7nm, 220 petabit per sec fabric, 20 petabyte sec mem bandwidth, 40 gigabyte on chip memory, 2.6 trillion transistors, 46225 millimeters squared, 850,000 cores. I say 50k, not 800k. So. So, yeah, those are some numbers that we wanted on day one. Size of the core. So 2028 micron times by 170 micron in square nanometers. So that is 0.03876 millimeter squared per core. What it is, okay. Fabric 2D mesh, 5-port router with 4 neighbors and core, 32-bit cycle bidirectional transfer. Carries 16-bit payload. And a 16-bit index. We got latency between cores. Hardware broadcast. So now we're talking about cross reticle bridges. Sub 1 millimeter across scribe lines. 1,000 plus wires per die to die edge. Need redundancy. So sub fabric bandwidth is 7x GPU, into a sec in gigabyte per sec per millimeter squared. 0.15 petajoules per bit going across reticle limits. It's 1/66th of the power per bit, or 1/10th at full bandwidth. So train large models like GPT-3 on a single chip without partitioning. Wait, streaming through memory X. That's Cerebras's memory topology. Weights not stored on WC2. They are flowed through. Okay, and gradients streamed out of wafer. Talking about data flow now. That's the reason why I'm not writing anything. Okay, next slide they're showing is the one I've already got up. So up to 100k mat mul, 100k by 100k mat mul does 75 peta ops FP16 sparse, or 7.5 peta ops FP16 dense. Oh, now they're going to talk about their scale up memory X and Swarm X. Can bring 192 CSC2s together through Swarm X and Memory X. Isn't there a company called Memory X without the O? Because technically the cores at the end of each die JOTO are slightly different to accommodate the fact you're doing a cross reticle communication. So you're not going to be doing those right up to the edge of the wafer. The reason why you end up doing you still print the areas that you're going to cut out is actually due to uniformity of the wafer. You want the dies to act as if they've got the same thing next to each other when you cut them, so you have a predictable dicing when you cut and predictable performance. Hey Mark. Took me 2.5 hours, but I finished all the watermelon. Just going through the last couple of slides. Chris too. They're both sleepy. I've actually toured the Cerebras headquarters in the Bay Area. Didn't take any photos. I was just there just to speak to CEO Andrew and just chill. It was really fun. Rebecca and I and Andy, I think, we went through one of the units, DC to DC conversion and all that, and the cooling, and first version and second version. So End of session. Okay. So, everybody ready for a break? So, another 25-minute break for switches, which is AMD, Juniper, and then NVIDIA. Yeah. I'm going to get another coffee, and I think I'll see you all later. I did see some questions. Johto, no public Cerebras yet. Where would I invest? That's not a conversation for this channel. If you want to talk financial, then I have routes to do that. So, yeah, I'll see you all in about 20 minutes. Are we all ready for switches? Just a minute or so to go. These breaks never last long. Go down, make yourself coffee, use the bathroom, and then you realize, time to get back. But AMD, part of the Xilinx acquisition. So this is what this talk should be. 400 gig adaptive SmartNIC SoC. Kind of sounds weird to say AMD and network interface card at the same time. So we'll see. Still looking forward to it. See if they got any. Well, they won't have any benefits of having Epic on it as well, but that will come. That will come. So people are asking if this comes from the Pensando acquisition or the Xilinx acquisition. This is part of the Xilinx stuff. I'm actually slightly lower right now because I changed my chair. So here you go, up a bit as I knock the whole table and spill my coffee. 1 second. This is the problem with having chairs with arms. You bash into your desk and everything flies. But we're starting up now. Let me move these armrests to just underneath the table so I don't knock it. No, that's not the right one. There we go. More centralized. Here we go. Jai Deep. He's presenting live. So. So, overview, solution, SmartNIC. Oh, they've got some good lighting in the studio. Hey, Jastra. Thank you so much. Hope you enjoy the stream. He mentioned Genoa and Bergamo. Helping offload workloads. That's just what it's not. Focusing on multi-tenant situations. Often have my network. Hope so. So basically, everything needs to be configurable. That's why you need an FPGA. So the West uses the NIST standards, and China has its own. That sort of thing. So. Excuse me while I choke to death. I swear, when it comes to breathing, I'm the dumbest person. Can't even get that right. All I can say is learn to do the Heimlich maneuver on yourself. You never know when you might need it. It's because I take a drink and I don't focus on drinking, I'm focusing on everything else, but he's just reading through slides kind of right now. It's a very good presenter. Yeah, it's worse when I have when I start eating chips, so so basically if you do everything right, then you get your solution. And we're speaking about solutions again. For the next few years, every presentation is going to be at about software solutions. So don't get too comfortable. Ooh, cinnamon coffee. I used to have a lot of my flavored coffees, but I have them with sugar, which isn't that great for me. Need to cut back or use a fake sugar, stevia or something. So they're talking about SmartNIC blocks are tightly coupled. Programmable logic. Network subsystem. Host subsystem. Processing subsystem. Memory subsystem. Let's put some numbers here. Or acronyms. HNICX. CPM5N. I've put up the last slide of the deck, but CPM5N host subsystem PCIe Gen 5 or 6 or 2. Yeah, so there's a diagram, which is a diagram on the left of the slide that's showing, and they're just going through each of those individual parts of the new SmartNIC. So CPM5N. I don't understand how a host subsystem migrates to that naming. Composable managed 5-way network? I don't know. Tesla Keynote will be about AI through system integration. So if you check hotchips.org, it's got the full agenda up there. So this talk's already going deep into networking requirements at SmartNICs, so this 400 gig switch, it is 400 gig total. It's not 400 gig Ethernet, so it's 2 by 200 or 4 by 100. We get to the point where the number is the sum, where it used to be just the peak. So JOTO, that's MPPS, million packets per second. Measure of that sort of stuff. So DDR controllers, now we understand memory subsystem. This is interesting. There's a DDR controller bypass mode for storage class memory. PHY also supports other standards such as MIPI. So processing subsystem now. LPD is 4 times Cortex R52. That's 32 KB T128 KB TCM private. FPD. That's Gbps. So everything is 256 gigabit per second, except for the programming logic, which is programmable logic is 512. Going this deep into networking is a bit beyond my pay grade. Okay. Confidential compute now. Check, protect. So 3 methods. I should put this here. For networking, I'm pretty sure in-flight security is required for a NIC. Ooh. We're going to go into the use cases, which is offload and virtualization and yeah. Point is, ideally, when you have multi-tenant situations, every bit of the hardware in the chain should be able to have a end-to-end security, but also as data passes through devices, they be isolated from the other elements that might use that device. So, for example, multiple tenants sharing a NIC. Now, you can encrypt the data, but that's not to say that the data in flight can interact with each other. There's that level of security, so doing it that way as well. They say full OVS, but they haven't mentioned what OVS is. So, open vSwitch. That might be useful to know. Dave, yeah, it's been around. If you've been in that space, I expect you to know it. Ooh. I mean, it's only 8 p.m. That's why I'm yawning. All this stuff is why you can't get a system, add 4 1 gig NICs as a card with 4 1 gig NICs, add 10 of them into a system with a standard CPU and use that as a switch. So don't get me wrong, that's something I thought about many, many years ago. It's like, why couldn't I do that? Turns out it adds a lot of overhead and a lot of latency. Or it can do. Especially if you're a student in a shared house and someone won't turn his torrents off for the rest of the house and you want to limit them. Maybe it's easier these days. So now we're in this final slides that I've got up there, so 1.6 terabits second. I guess that's only 200 gigabytes a second. LPDDR5. So oh yeah, it's probably coming, Kin. AMD AECG team. Remember that. Q&A. Is this a planted question? Oh, excuse me. Talking dual socket Bergamo. And my stream has paused. How's everybody else's stream doing? Oh, okay. Here we go. They're both. Let's ask an AMD guy about AMD. Yeah, Darrell, it doesn't. He didn't say where these questions are coming from. So, he said we're the first one. I hope Mark isn't doing that for all the talks. I mean, okay, Chair can prepare questions when nobody's asking them, but there are plenty of questions in the Slack. So use them first. So, anyway. Now we have Juniper. Spark and P6 this guy's got used to work on. If Juniper evolves, is it going to be called Jin? X-Brive ASIC, and this is a family. Everything is preliminary. He's got a green screen, but they're not using it. So. Problem is, if you green screen to go transparent, it doesn't work when you have a white background on the slide behind you. So we're talking about Express ASICs with the programmable pipelines for bandwidth and energy efficiency. And I'll leave this slide up because this is the most relevant slide in this talk, I think. Show me a system with 4,600 gigabit Ethernet ports where each port is 100 gigabit. That's insane. This is just connecting a whole data center together through what literally the spine, right? Yeah. So you're just using literally one of these, excuse me, one per data center, or at least per floor of data center. Assume, yeah. Hey, Matt, interesting stuff's probably going to be a bit later, like 3-4 hours later. I mean, yeah, if it's spine top of data center networking, I'd assume it'd be hundreds of microseconds. The fact they're saying 3 billion bits of on-die SRAM is just confusing. I do remember seeing lots of is it Altera FPGAs with hybrid memory cube supercomputing 2015, 2016. So, yeah, what they're doing here is a chiplet. So, and that's when you get the slides that I'm showing at the top there. Stop saying billions of bits. Oh. Yep. That's a lot of balls. Question is, Dave, how much do these cost? What did I put? MagSec. Yep. There you go. So 8 products, basically. There's 2 types of chip. Some with HBM, some without. Depends how you put them together. Connected by this XSR link. Everything else external is LR. Extreme short range for on substrate, on interposer, whereas long range for everything else. Oh yeah, there's ASIC 2. I'll leave ASIC 2 up. I was hoping they'd actually show off some silicon, but no, probably not. The next talk after this is NVLink. So Yeah. This will be their 23-24 product line. Especially with the co-packaged optics solution. Perhaps one of the limitations at Hot Chips should be show us your chip. I hope somebody's asked in the Q&A. What was that? Rants are good. That was a good TDP rant. Dave, everyone, it's fundamental raw numbers. We want to know how many transistors, we want to know die size, we want to know power consumption. I wasn't listening to the question. This was Nathan's question. Oh, that's interesting. So that they're doing a more outreach about networking. Guess who's looking for clients? If you want to expose this stuff to students and teachers, you need to work with influencers. It's literally saying, yeah, they want to reach out. So oh, I know. Some of these companies are so embedded. They're very focused on what should be said externally with what the media market was 10 years ago, not today, or 20 years ago. So let's do an article in E Times, Semiconductor Engineering. Video, what's that? But they had a green screen, so
What's your minimum specification?
These slides are very dense. I'm not sure how much I'm going to be able to translate. It's just lots and lots and lots of text. Basically, we control the stack from hardware to software, so we optimize everything, including the routing. Insert NVLink. So this is a slide that I've got up online now. I'm going to have to write all of these out because it's important. Okay, so NVLink4 enables CPU to CPU connections now. Can't use off-the-shelf cables. DOJO, no, they still kept it at 50 gigabytes per sec. So this is what's going to be deployed with Hopper in the DGX H100. So whenever Sapphire Rapids is ready, basically. These slides are dense. I think I've got a moth in the room again. Yeah. It's a lot of slides. Yeah. When you scale out to multiple GPUs, you have communications problems that you have to sort out. Solution, better communications, or just a bigger single chip? Offload. Saving data in out GPUs. You're moving some of the compute to the switch, which increases the power requirements of the switch, reduces your data flow. Yeah. You know, the usual stuff like that. So. I didn't realize the NVLink network switch, it can only be configured once on boot time. Now with NVLink4, it's hot swap. So yeah, you can adjust connections live. So yeah, Joe, it's gonna break some things. It's not stuff's not gonna be forward compatible. You're gonna need to recompile. I don't think NVIDIA's cares much though. Somebody should ask the question is, does the changing in a global address break forwards compatibility? Ask that in the Slack if somebody can. Ask if the change from the global physical memory address to a local physical memory address breaks forward compatibility of current workloads. The question that Johto was saying. Yep. No, they're not, Justin. Nanda Gopal, thanks for the 400 rupees. Appreciate it. It's funny how Streamlabs OBS puts it through in the... Yeah, no, thank you. Much appreciated. Daryl, I think I'm simultaneously out there. That's important. And just talking about spine leaf and all that stuff. Hmm. Should we come up to the Q&A? Last slide. These slides are dense. And they're too dense for this, but... I probably do.
What's your minimum specification?
He's answering the question by giving an example after already answering the question. You don't need to give an example. The guy asking the question clearly knows. That's why he would ask that question. Yes, I've handled a WSE2. I've gone to Cerebras' headquarters and had some fun. I think it's the other. There's another Moore's Law is Dead guy in at Hot Chips this year. Guy called Christoph. It's not Tom. Weird answer. Weird answer. We're 5 minutes over. We should be going into a break now. So somebody hit the audio. Mm. Quick announcement before lunch. Well, the message was simply there's going to be lunch. So I've adjusted the schedule above. So now because we're late in the day, we're just going to list all the talks left. Lunch and then Tesla at 2 p.m. Then straight into 3 talks that are basically NVIDIA and NVIDIA partners. So 2.5 hour session, then a half-hour break, then a 2-hour session. Yeah. So the keynote should be interesting. Obviously, I'm looking forward to Grace. Then there's the Intel Meteor Lake stuff. So we're gonna go for that. I'm gonna go get some lunch, and I'm gonna need some of the stuff that Pat Gelsinger was on yesterday. Pep me up. Maybe it's just enthusiasm. Maybe I need to be more enthusiastic, or it's calisthenics. It's I'll see you on the flip side. See you in about an hour or 50 minutes. Hello, hello, hello. We are starting again. And I need to update the slides for today. Add files. So for the next few talks, didn't have the slides ready because they weren't ready in the system. So let's go with those. Hope you're all doing well. Hope you managed to get some lunch in. It's getting quite clammy. I had to take a shower. If you're wondering why I'm putting lots of right brackets, it's because that's my let's move the slide button. Okay, Dojo. So yeah, next session should be starting in just under 3 minutes. I think so. This is going to be a 2.5-hour session, starting with Tesla, then NVIDIA Orin, then NODAR. I just had a look through those slides. That's about autonomous vehicles, and then there's Grace, and lots and lots of Grace slides. Well, so the Tesla keynote is going to have lots of slides. I think, yeah, I said before there was 87 slides, so not sure how they're going to get through that in an hour without going over, but we'll see. Let's go for here. So now we've got 4.5 hours of talks and a half-hour break. That's the next 5 hours. Hope you're all sat and ready. Let me just have a flick through of the Tesla keynote. Requirements of machine learning. How the future is going to evolve in machine learning, what we need to do with machine learning, all the different ways in which it will evolve machine learning, the software, hardware you need to do it, how to cool chips, how gaps in compute versus memory are going to expand, how you need to re-architect the data center, can we do better? Yes, it's called DOJO. And a small reiteration of the talks we've already had. Software, programmability, complexity. Yeah. So, we'll see. And it's Ganesh Van... I always mispronounce that. Venkatara Menon. He's the one who did the presentation of Dojo at AI Day last year, so... Are we starting? Hot chips. A couple minutes behind. And I think the slides for Meteor Lake are already up for everybody who's at the event. No doubt somebody's already posted them all online already, but that's the way it goes. And here we are. And I've got no audio. The pre-recorded talk. He's presenting outside. The brackets is my additional. I mean, we flame everyone. Ariane. Evolution of compute. Data in, process data out. That's literally the slide he's showing. Source, Google Images. I don't think you can say source Google computers to get around copyright. Not everything on Google is royalty free. It's public domain. More data, lots of data by 2025. Zettabytes. More things happen. We record more of it. The type of data is changing over time. %80 of data is unstructured. Do you count video data? If I record a video, is that unstructured? Giselle, don't think I've ever seen a filter for usage rights. Okay, I've never seen that before on Google image search. So interesting. People's computer requirements increase logarithmically with time. That's his argument right now. So Giselle, I'm looking at images. I'm looking at image search, and I can create Creative Commons licenses or commercial licenses. Not, I can't sort by only open licenses or only public domain. So some of them are attribution. Yeah, so yep. Now he's talking about, again, new processing models. Huh. Machine learning techniques, climate AI. Only machine learning can enable real world data to be used in training. Yeah. Or only real world data can be processed through machine learning. That's the argument he's making. No, sorry, something my nose. If you you can't put links in the chat, Ariane. New types of cores. Sorry, my nose, it's been going all day. Hey James, how's it going? What is AI? What is ML? What is DL? Huh. What was the question about the link? Sorry. Iterate on data with new architectures and you get useful outputs. That's literally what is. It's. I think this talk is pitched too low for this conference. We have had years and years of AI talks, including 2 from Tesla today, explaining this. So, should be 10 minutes in. Now he's talking about how machine learning training, the process of it. Dukedom so far, though Musk isn't giving this one. So you need an algorithm to label your data, and with the labeled data, you can do training. Does it matter that it's in JSON? I mean, I've worked with JSON, as long as you can, it was fair enough. Hey, Raymond. If humans are in the loop, progress will be slow. I need to... I assume it's going to do, trucks, commercial, UAVs, aircraft, anything that requires visual manipulation, so... I mean, are any other companies close to deploying something like FSD at scale? Yeah. It was 12K and now it's 15K. But all orders before September 5th will have the previous price. So, I mean, I did a poll last year, maybe the year before. What would people... Oh, I'll do one in the chat here because it's relevant. Level 5 is fully self-driving, as in you can take your hands off the wheel, be in the back seat. You don't even have to have a steering wheel or pedals. It will just take you where you need to go. You literally put the address you want to go into a sat nav, and it will take you there. You can put your feet up. You can sleep. Assuming that all the legal requirements were sorted. I mean, yeah, that's the point. You get your time back. If you need to go somewhere that's, say, a 2-hour or a 3-hour drive away, you can sit in the car, watch a film, answer email, take calls, read the paper, do work, or catch up on sleep. And the whole point about, basically what you can do in a taxi. Level 5 is a taxi. Right? So I mean, you can still have level 5 with a steering wheel if you really wanted to take control. Imagine it's like an RV, but when you don't want to take the wheel, you can just stand up, go use the bathroom, right? So, I mean, we're seeing, was it, 23 votes. It's not a lot. Half of you will pay up to 10%, a third will pay 30%, and then we've got, 8% up to 50% more, 8% up to 100% more. I'm probably in the 50 to 100% more category, right? I want my time back. If I'm gonna drive somewhere, if I'm gonna go visit my parents, that's a 1.5 hour drive. I'd rather be doing something rather than driving. If I want to drive, yeah, maybe I can take over and whatever. That would mean I'd have to get a license, but that's a different issue. So, yeah. He's still talking about AI systems and what we need to do to increase compute. Need to increase effective compute by having the right hardware. And this is assuming level 5, works and it can be trustworthy, right? The next step would be, do you support, will transporter technology, right? I mean, level 5 makes sense for cargo, right? Or if somebody needs to be picked up from the airport, rather than parking at the airport, you just call for your car to come home. And yeah, the simple solution is a taxi. A taxi is what that is, or public transport. Public transport is a bit different because you can only get picked up at defined places and dropped off at defined places. But yeah. So the thing is, if I have a car and I drive to the airport, that Uber costs about £20, $20, whatever. What is the cost in depreciation and fuel and my time for that journey? It's about 20 minutes. So it's talking about different ways people have tried to mitigate against compute. There's an argument for active and passive learning, true, but you can do a lot more if you're not having to focus on the road. And sometimes it worries me how much people don't focus on the road, but that's just me. James, is that just for fuel, or is that also including depreciation? It depends how much a car is worth, I guess, but... Do you ever have to turn the music off to concentrate? That's my problem with driving, with, trying to listen to something at the same time. Hey, Jeff. Thanks for the 5. How's it going? Yesterday we did 9.5. Today's going to be 11, Jeff. So strap in if you're following along. Ugh. I mean, efficiency is good, but everything's got an efficiency curve, right? And the further the lower efficiency you do, generally the higher the peak performance. And sometimes it's the peak. Sometimes your limitation is something else. So you want each chip to be peak and you're prepared to spend the extra power. It's like the most efficient place for an Intel CPU is about 2.53 gigahertz. Nobody runs it that. When you're idle, you run it that, but when you actually want work done, you run it faster than that. So
What's your minimum
I'm sure there's a drinking competition, Jeff, where every time they say machine learning or AI, you take a shot. That being said, 28 minutes into a Tesla keynote and you would be in the hospital.
Specification.
Data and architecture evolution. It's all about connectivity. Focused compute and connectivity. So far, he hasn't said anything much that people at this conference shouldn't already know. So, I mean, NVIDIA has 2 of the next 3 talks. So you'll see up here, Orin and Grace. It's NVIDIA. Durrell, have Thermosiphon showed off the copper one? Gate all around will have a positive effect on efficiency. You'll be able to drive down voltages. So James, in the previous section, we had networking and switches, and SmartNICs and DPUs and other stuff. That was when that was covered. Okay, yeah. I've been planning for hot chips, so haven't seen it. I'm talking about, yeah. You need specialized silicon for compute, you need specialized silicon for switching, you need specialized silicon for memory. It's, yeah. It's basically, this is boiled down to we need more. I mean, you see the slides that I've got on the stream, it says training tile. One of Tesla's exapods, or whatever they're calling it, as we learned this morning, is 120 of those tiles. That's a 3x20 array, and it's dual layer. So now he's talking about D1 chip, 400 watt TDP. We've got these numbers already, but I think that's FP32. Tesla's unique innovation is chip on wafer. 9 petaops on a single tile. So saying that 362 times 25 is 8. Yeah, that might help. So packaging, use all fan out layers. So 1, 2, 3, 4, 5, 6, 7 layers in the training tile. And now they're showing the slides that I've unparalleled integration. Yes, but with a PCIe card, the cooling required is sufficient and the power is on board. In order to have a compute tile, you need something like a 12U system. And now they're showing what is a fully dojo training matrix, which was in the articles we saw before. So on the edge of this 2D array, you have 5 dojo interface processors, which are connected with, 5 dojo interface cards, which have 2 processors on each, connected with HBM, and that's connected to the host CPUs. So somebody needs to ask what the host CPUs are on Dojo. So, and whether you actually need one CPU, how many CPU cores do you need per interface processor? Because I'm not on the Slack, I haven't, because I'm doing this, I can't ask all my questions, so other people have to ask them for me. Or I need another monitor. I've only got 2 monitors. Yeah, 2 monitors, one there, and then the laptop which I'm actually watching the conference on. They have their own what are they calling it? They're calling it Tesla training protocol over Ethernet or something. So it was mentioned earlier in the day. Let's see if I can go back. It's already been 50 pages of notes. Yeah. TechTechPotato over Ethernet. That's what. Yeah, so the title of my video about Dojo should be TechTechPotato over Ethernet. There we go. And then they connect the interface cards are connected over PCIe. So What slide is he on? We're more than halfway through now. And so it's got about 9 slides left. So this talk's going to be about 45 minutes. Now citing slides or stuff from Alan Turing. Poll finished. There we go. 50% of you would pay 10% more, about a third, 30% more, 10%, 50% more, and 6%, 100% more. What laptop do I use? This one. It's a G14, the 6900 HS Rembrandt. You need a software stack. In order to get that laptop to say more than more, took me 2 hours on an aeroplane trying to fiddle with Asus's software, which if you try and write words doesn't work because you need the right font, you need it in the right place, and there's no XY movement offsets you can place. And if if the font's too small, if you've ever tried to write a font on a limited DPI display, it looks terrible. For anybody that's wondering, that display takes another 3 or 4 watts out of the battery. So if you're using 7 watts normally, it 10 or 11, so you do lose about a third of your battery running it. Jeff, it would have been easier if they just said, you have 5 lines of text. You can make it any size you want, and for any line, you can apply an XY offset. If they'd allowed that, it would have been so much easier. So I think, so you can select whether you use 2, 3, 4, or 5 lines of text. I'm not using the 5-line of text mode. I'm actually only using lines 1, 2, and 4. All 3 are different fonts. Some of the letters are capital, some of them are lowercase. And then I had to add in white space with a character at the end in order to get them to line up. So okay, looks like he's finishing up last couple of slides. I mean, I appreciate the talk, but it's stuff that everybody's covered up to this point. Really has. Oh, you can't do non-alphanumeric characters on that display either. I've tried. Try and put an emoji in it. Nope. It's Windows software, as you might imagine. But all the software I use is on Windows. Architecture, integration, disaggregation, abstraction, algorithm, compilers. The thing is, disaggregation only works if you don't have an at-memory compute solution. And the problem with an at-memory solution is you have a fixed amount of compute to memory, and if that ratio ever changes, you need a different chip. So now they're showing 122 years of Moore's law, and it's like a Moore's law graph, and they've got everything from IBM Tabulator, Colossus, IBM 360, Pentium, Blue Gene, GTX 680, then TPU v4, then DOJO. The one they haven't included is Cerebras. And Cerebras is the biggest quote-unquote competition to this. DOJO has more integration. Cerebras is wonderfully less complex, and we got a deep insight into the architecture with Cerebras earlier today. Again, and now the second or third quote from Turing. And that's it. Q&A time. See you, James. Have fun. This is a stupid question because they said that in the AI day. Excuse me. We can refine physics anytime. Good to know. They answered this in the previous talks. Did the chair not watch the previous talks? Please tell me he did. Come on. Dear God. If you're going to be a chair at Hot Chips, and the company that's presenting in your session has talks previously during the week, watch them. Especially if they're the same day, hours earlier. Doing it in-house means you can cut a few corners as well. I mean, they already spoke earlier about the fact that they don't really need any security because there's well, security in the sense of to get into the data center, right? Or to get data into the data center. But they're not going to have multi-tenants or anything. Whereas with a commercial solution, you have to spend silicon on confidential computing and multi-residency. Still many more hours to go. Hours to see. And I'm using a $6 keyboard. It's getting tough. Is he actually asking questions from the Slack? I hope somebody passed him a note saying Please mention who's asking these questions. Hmm. So, which tech publication is going to say Dojo 2? Tesla announces Dojo 2. Tesla to work on Dojo 2, and it's just going to be that Q&A, that final Q&A, whatever. Next session is going to start in a few minutes, so we're on time. Now we're moving into the ADAS and Grace. So Orin, NODAR 3D vision systems, and Grace. So why isn't it showing the... I'm going to need to take some of these. Okay. So this is Orin. There we go. The slide. You know, specs. That's basically that slide that's already up. So, yeah. The first bot of the day. Have fun. First bot of the day. Redundancy. You need the 4 10 gig Ethernets for redundancy and connectivity to other stuff. The CPU complex looks like this. Stevie, what do you mean? Oh, that? Just still got the wrong link online. The Geekbench 5 scores. Oh, they used megahertz. Memory running at 3200 mega transfers per second. Come on. Come on, NVIDIA. You know this. Can somebody confirm if the DRAM was running at 3200 megahertz or 3200 mega transfers per second? I mean, if it's LPDDR5 6400, then okay. Hmm. The answer to your question, Stevie, is should it be gigabits second for RAM? No, that's the full memory bandwidth is in gigabytes per second. Orn. It's that Orin from the south. Orin. I believe it just means it's on its own voltage rail. Warren. Either, yeah, it takes its power from an independent rail to the rest of the CPU. Now, whether that rail is downstepped with all the other rails or separately, don't know. Brian, thank you for doing the math. Yes. So DDR5 6400 is 51.2 gigabytes per second per 64-bit link. There's 4 of those. 4 times 51.2 is 205. So, yeah, it's DDR5 6400. Okay, NVIDIA. Good. Good in the sense that it's the right number with the right unit. Bad in the sense of you should have just used transfers per second. Because nobody says DDR5 3200 megahertz. Unless you don't know the difference. So. That's half. Yeah. Right, 52 tops, but the Yeah, there must be two deep DLA, deep learning accelerator. Just so basically it's an int 8 engine. So there's two of these DLAs. There's got to be. You got briefed, Ryan? Or do you mean from their document online? It's always important to make sure that if you put numbers in a presentation that they add up. Or they multiply together and add up. Oh, that's why you need the Ethernet as well. Whoever asked earlier. It's so you can do multiple Orins. Though, that being said, the slide doesn't say whether the connections are through PCIe or through Ethernet, so we'll see. Also, AV1 encode decode 8K60 support. Yeah, 10G Ethernet. Improved optical flow accelerator. Improved image signal processor. Gen 4 PCIe. So eight as it depends on the power on the encode, right? Yeah, so Connection via PCIe, just to confirm that one. Oh. Ethernet. Point is, if you put 4 Orins in the car in various places, then Ethernet might be easier. After this, there are 6 talks left. You got NODAR, Grace, AMD Intel, Mediatek Intel. AE might have a different licensing model from NVIDIA. So technically, because Geekbench scales roughly with spec, does that mean we can estimate the Geekbench numbers for Xavier as well? Yes, AMD's SmartNIC was also using A78 SE. I'm going to be right back for a second. They're still going through the last couple of slides, which I've already written up in the notes before the Q&A, so... Good, get me my Monster Munch. Ooh. Given that I choked earlier eating watermelon, I'll need fluids for as I eat. Some Monster Munch. Flaming hot. Everyone should try Flaming Hot Monster Munch. Woe betides the person who picks pickled onion. I don't understand that if you want to buy individual packets, most places have pickled onion and roast beef. The third flavor is flaming hot. In my opinion, the first flavor should be flaming hot. Flaming hot Cheetos aren't the same. It's definitely not the same. NVIDIA, the only people. NVIDIA, the only one to quote sparse. It's because Cheetos aren't sweet enough. I mean, a lot of... We talk about Americans eating, quote-unquote, lots of sugar, but it's... Not a lot of it is that's sweet. Well, I mean, chocolate with the butyric acid is a thing. The end of the talk. Now we have NODAR. It's like radar, but no. And yes, the guy's called Leaf. We got going now. Good. Hey, Curious. Thanks, Johto. Appreciate it. 3 evergreen trees.
What's your minimum specification?
Okay. I think it's still kind of crazy that you want to get under 3 kilowatts in a car, but so generate a point cloud that you can have algorithms work on. If you don't know what stereo vision is, so a stereo vision camera just measures distance. Baseline is difference between two cameras. The wider the baseline, e.g. 3 meters rather than 20 centimeters, the range increases. Well, but calibration is difficult. So yeah, this company is implementing a software solution to build wide baseline stereo vision cameras, because it's very hard to do in hardware because of cars vibrating down the road. That's what it is. So if your two cameras are very close together, it's very easy to align them to get the point cloud, but your range is limited. If you want further range, you put your cameras further apart. If you put your cameras further apart, the alignment need is a lot more strict. And because a car goes down the highway like that, it puts them out of place. Try and do what you can physically to minimize that motion, but it's not perfect. But if you can fix the data in software, then your range of capability in that vibration increases. And if you have a wider range, you can use it for more places, and that's how you get 2 kilometer distance support with these wide baseline stereo vision cameras to generate 3D point clouds that you can run the AI on for autonomous driving. That's what they're doing. They're just going through some of their demos that they've done using an open dataset from Ford. You have to get them to work over a wide variety of situations, you know, driving down the road, driving under a bridge, perhaps going off-road. And their block diagram is basically image, compute, done. Because they're VC funded, you know, they're looking for either big customers or being bought out or IPO or whatever it is. Did I get any other slides? No. So I got more slides. Yeah, here we go. Optimization problem. It's a 24-dimensional problem. So yeah. Set 6 spatial, 18 others. So all the 18, so in the slides that I've got on the screen, you see this under the image of the two cameras, there's a 6 underneath that, which is roll, pitch, yaw, and then XYZ. And then on the right, you have 9 degrees of freedom for each camera. That gives you the 18, so you have 24, essentially a 24-dimensional problem. So basically, you got to solve for the correction for each of those dimensions. That's why it's a difficult problem to solve. I mean, this would make a really interesting video going through some of these slides. It'd be nice to get a hold of some of the video of this. I really should make notes of what I should be following up on after this. No. They haven't said anything about fog. If anybody's got people who are in the Slack, ask about fog. And we have another bot. the more you save, the wider the market. Drones, UAV under 5 watt, last mile delivery under 20 watt, consumer under 50 watt, robo taxi under 100 watt, commercial under 300 watt. VGA 20 FPS, 2 megapixel, 30 FPS, 5 to 8 megapixel, 5 to 30 FPS, 200 plus meters, 50 meters, 400 meters, 5 to 8 megapixel, 5 to 30 FPS, 200 plus meters, 5 to 8 megapixel, 5 to 30 FPS, 400 plus meters. Right now, what 5 FPS, 5 megapixel. Using NVIDIA hardware next year. Computational power available is roughly proportional to vehicle mass because kinetic energy is half mv squared. Oh, that wasn't. Yes. Try and superscript something, and that just increases Chrome, so. I like this talk a lot better than I thought I did. I think the problem is easy enough to understand as well. It's laid out relatively well. I would have changed some of the introduction to just to better explain what they're doing. But that's just me. I would have done more slightly pointed slides, but that's me. People talking about Nerf. I've been using software to do that for years. Why are people talking about it now? Can somebody explain to me why Nerf is... So you just bunch of 2D images and you create a 3D radial field. Mm. I'm surprised my mouse hasn't run out of battery during this event. It's the sort of thing I think it would do. I used to be wired, and then I did some competitive gaming. No, never again. It's got so annoyed with it. Over the span of like 4 years, getting too many instances being annoyed. Interesting. Cost pressure. Yeah, that was a good decision to run that talk. Hot Chips Committee. Well done. Grace. Grace. And my stream just stopped. Woo. Fun, fun, fun. No grace for you. There you go. Okay. Such a weird thing to say. We built the world's first super chip. Huh? What in the F does that mean? Seriously. But they've designed Grace to be essentially ARM standard in everything. So you can malloc memory on the GPU straight away. Or but now they're showing a slide that I've got up. So this completely new, or is this based on ARM CCI? What's the SCC? SCF cache equals, yeah, SCC. So the SCC is in that diagram. That's the darker blocks, darker gray blocks. That's cache. SCN, I assume, is scalable cache network. So
What's your minimum specification?
now let me see if I can find a slide. Yep. So this is the slide with all the cores. So 32 channels. I assume 16-bit channels. What this does is it increases the demands on the market for LPDDR5 5. That's what this does. So it's a small X, not a large X. So it could be LPDDR5 or anything beyond LPDDR5, that gets created. It's not a capital X, it's a small X, so that's kind of an optional. So if there is, say, a low power LPDDR5 LP, the idea is that it's supported. So bear that in mind. The fact that it's lowercase is important. No, they use lowercase x throughout, Dave, so... Are they going to talk about packaging? One of the questions is going to be what method, what... Okay. Okay, yeah. So memory bandwidth, how close is silicon? What form factor? Can I get a desktop with it? Oh, packaging. They're doing 1.3 petajoule per bit through organic. And will I be able to get one? Intel's first question. Can I get one? Will I get one that I can run? Can somebody ask if we can get one as a workstation? Oh. It's because I'm not on Slack. I've seriously fucked up this time, so. Yeah, okay. That's the end of the session. Okay, so yep, they're finishing up. We're on the home stretch now. Last set of talks up here. AMD, Intel, Mediatek, Intel. We've got about a 35-minute wait before they start. I'm going to refresh. I do need to grab the slides from the next talk so I can show you guys something. And yeah, I'll back in 35 minutes or so. Hey. Few minutes to go time. Thought I'd come back. These breaks go so much faster than you expect. Let me put some new slides in the docket. Add files, okay. Yep, there we go. Start off with some AMD. And I believe we're almost ready. This is the final stretch, final 4 talks. Including the Intel one, and I think I picked about 5 or 6 slides to share from the Intel talk, so you're getting some good stuff. I mean, for those of you who don't already have access to the slides anyway. So we'll see if people drop into the channel just for Meteor Lake. Not sure at this point. The timing. I mean, what it's 1 a.m. in the UK now, which means most of Europe is asleep. If they really need to front load it with some of these talks, so perhaps don't put Dojo at the end of the day or something. I don't know. But yeah, should be starting soon. The hold music between sessions is very classical. But yeah, AMD, Intel, Mediatek, Intel. So, and then, yep, this will be an 11-hour stream. Considering where we were a few hours ago, 9 hours ago. Is that what it says now? Yep, live just ticked over 9 hours. So currently it says average view duration 17 minutes. That's higher than yesterday. Viewer count is about half though. It's doesn't always go as second day doesn't always go as well. The chair is from Tesla, so and he's just going through some of the admin. I'm gonna have my last packet of Monster Munch. Hope you all got something tasty. Yep, this is AMD Rich. They have in a few places, but yeah, depends who you trust. I think this is a live talk. So yeah, so Intel did a pre-brief for hot chips, but it wasn't specifically Meteor Lake. They gave out some vague slides, but they didn't really say much. They just said tune in. So that's what went live beginning yesterday. But yeah, the rest of us, there are a lot more slides that weren't part of that briefing. So it's just talking about stuff that I hope most of you know. Just some. So Janus, there are a lot more packaging slides in the full deck. Oh, about Microsoft Pluton. I wish they'd give details about it. I mean, official details. Somebody in the Slack should just ask what the F is Pluton. Or at least, can you give us a deep dive into Pluton? Because all we've seen is third party. So, I mean, yeah, just currently going through the slide I've got up there. Five layers of power optimization. Core, GPU, SoC, platform, software. Unmatched system, so what? And performance per millimeter squared. So, Just a problem with Pluton is that it's meant to be a Microsoft technology in AMD, Intel, and Qualcomm chips that run Windows. But the best data we have on it is a third-party analysis, because none of those companies will talk about it publicly. Not Microsoft, not AMD, not Intel, not Qualcomm. So, I mean, aside from that third-party paper, Charlie from Semi Accurate, I think, had the best take. We don't know what it is. And while it might be fine and dandy in the US, what's to stop foreign governments getting involved as well? Thanks, Evan. Appreciate it. Yeah. Upvote those Pluton questions. Also, if you go to the Slack channel for the Tesla keynote, I've got a thing there. Can you upvote it so they see it, please? No, Pluton is something else entirely, Daryl. It's just part of the issue. Just what's my next slide? Yeah, graphics. Strong lights, and it's night time outside. The windows are open, so the bugs are getting in. Fantastic. It really is the battery life that everybody wants. I mean, I use Battery Bar Pro really just to make sure how much battery I'm using, because that does pretty good counters. Yeah, Arduino 2. They changed the naming, so now it's more like the standard stuff. Just gotta be aware that Ryzen 5 has essentially less than half the performance of the Ryzen 7. So with the framework stuff, isn't Intel involved as well? They're trying to help them out with co-design. They must be. I know, but I wonder if one of the limitations is you can only use Intel. So no VIA for you. Or no ARM chips. I don't know. Yeah. Yeah, stronger design support. Intel has 10x more people working with partners designing systems than AMD. It's just a function of size. Eight, 9, 10, 11, 12, 13. Yeah. Internal on-die linear regulation. So, yeah. I mean, does OnePlus have any physical stores? And I don't mean franchises. Maybe in China, but still. Didn't in the beginning. I mean, yeah, it's as Warren says, big OEMs matter most. They're focusing mostly on the commercial side, so B2B laptops. Now, how many generations of reasonably good mobile processors have they had now? 3? It takes a few gens to get them on board, plus Intel is doing volume. Plus Intel is more competitive in the mid-range, mid to low end for notebooks. It's only the high end where AMD's being really competitive right now. I mean, that's where the highest margins are, so if you're selling everything you make, it might as well be at the high end. Available on only on OEM-enabled systems for the active audio noise suppression. I mean, does this count? The G14? I don't know. If it did, I would like to know, and I would like to know why it's only real time and not post-processing. So the 1 watt panel support, that's something Intel announced a couple of years ago. It just basically means validating certain panels to work at 1 watt. It typically means the brightness of those panels are limited as well. So you might only get 250, 300 watt, 250, 300 nit brightness out of them. Intel has that wrapped in the sort of Intel Evo stuff. AMD doesn't have that right now. Warren's got a point, especially now that a lot of vendors, you know, are using LPDDR, and so you got memory. But take this G14 that I'm using, right? This one. It has, or one of the other ones. What did it have? So it had onboard DDR plus a SODIMM slot. So you essentially shipped with half the memory bandwidth. I think the 4000 series G14 did. And so you only get half the memory bandwidth. It's frustrating. How much battery life does your CF19 get, though, at 1000 nit? So the problem OEMs have is that if they sell a system, they will get customers who turn around and say, well, I want to upgrade the memory. Why isn't there a spare slot? Or, I'm going to upgrade the memory, but the slot's already occupied, so I've got to buy twice as much. Not realizing that if the damn thing ships without that memory module installed, you've only got half the memory bandwidth and your performance tanks. Then they complain that the performance is crap. And so the response from the OEM should be, well, buy the highest spec at the point of purchase, in which they go, oh, that's too expensive. It's, you either give in to your customers and sell crappy systems, and that's like a negative spiral, because then the people complain about those systems, so they have to get worse in order to increase customer satisfaction, or the OEM has to turn around and say, deal with it. And unfortunately, not enough OEMs are willing to do that, because people in these companies have targets to meet, sales targets, and their job is not worth losing over trying to do the better thing for customers. I mean, it screws them in the end, but that's what it is. At Janus, they may have 2 SODIMM slots, but they may only occupy 1. And also on top of that, some system configurators, now this is really stupid, won't tell you the config of the memory when you select it online. So if you select 16 gig or 32 gig, you may only get 1 module installed. With their argument being, maybe you want to upgrade in the future. Not maybe you want maximum performance today. And then, but everything that gets sampled for reviews on either YouTube or written websites, that's got all the memory channels supported and filled in, because that's how they ship those specifications for review. That's what it is. If you go to anandtech.com/show/10,000 in numbers, you'll see my report on AMD's Carrizo platform, where AMD and the OEMs shot themselves in the foot with what could have been a good platform. Could have been. It wasn't, because everything was gimped from the start, and everybody in that chain made it worse. So oh, nope, that's the wrong one. This is what I get for moving around my chat window. No, you need to do HTTPS. They're not answering anything about Pluton, that's crap. Great. Sorry, Jim, these are crap answers. Well, these are really stupid questions. If you're going to present, why the... It's not path to memory, it's path from memory. Oh, for God's sake, Jim. Understand the question. Oh. Oh my God, I'm gonna... I don't think the chair understood Charlie's question. That's why he asked it. Charlie's question was meant to be facetious on purpose. Jim, if you don't like answering questions, don't present at Hot Chips. Worst Q&A of the whole show. Yeah, the chair didn't understand Charlie's question. Charlie's question was perfectly fine. That's okay. I'm only saying the fact that if he understood Charlie's question, he probably wouldn't have asked it. But it was a good question to ask. It's the fact that Jim didn't answer it. And here we are with the Intel talk that everybody's waiting for. I'm not sure if you see previous Hot Chips events, PJ, but I called shit out. Which is annoying because I work with most of these companies on a very regular basis. So, okay. This is a talk that everybody's been waiting for, so... This has got some nice stuff in it, so let's go through it. Monolithic CPUs don't scale. If you take anything away from this presentation, it's basically that. So... just going through the initial... We need lots of compute. 100 billion... connected devices. So, give it a couple of slides and we'll get into the meat and potatoes. Yeah, okay. So we're on disaggregation, basically going from monolithic to chiplet. Something between monolithic and chiplet. I'm pretty sure after this event we can officially say that Intel's using the chiplet technology. Tile has gone. Whoever thought they could direct the market by saying tile, it's gone. Monolithic was always best for perf, but chiplet was better for flexibility, pace, scale. So find a happy medium, which basically means packaging. So yeah. So now we have this slide which I've got up here, and you know the key line here is Ponte Vecchio, 47 tiles. N7, N5, Intel 7, 3D plus 2.5D, that's 36 micron Foveros. Plus EMIB. I mean, Evan, it would have been a nice delineation to make. The thing is, nobody at Intel believed it. So that's what it is. If it had been hammered home, if it had been obvious to the engineers at Intel, they would have done it. But so far, everybody said chiplet here, so. I mean, imagine if they'd called it an iTile. I for Intel. Maybe that would have caught on. Maybe we would have told them it was useless. But, yeah, so. Not all transistors are the same. No transistor left behind, or whatever Raja says. Yeah. Now we're going to talk a bit about packaging. I haven't got any of the packaging slides because we've all seen, well, I hope you've all seen stuff about Foveros, Foveros Omni, Foveros Direct. So standard package is bump 100 micron density, bump density 100 per millimeter squared, power 1.7 pejoule per bit. Then we have EMIB, which is 45 micron, about 500 per millimeter squared, and 0.5 petajoules per bit. And Foveros, which is 50 to 25 micron, 1000 per millimeter squared, 0.15 petajoule per bit. Then you have Foveros Omni, 25 micron, 1600 per millimeter squared, and under 0.15 petajoules per bit. Then we have Foveros Direct, which is 10 micron, 10,000 per millimeter squared, because it's a square law thing, 0.05 petajoule per bit. And that density is only if the signaling works. If signaling doesn't work, you obviously have to be bigger than that. So Intel is currently here. AMD's Vcache is here. That's where TSMC is, so all the packaging is done at Intel as far as I know, Gustavo. I mean, Foveros Omni is what we used to call ODI, what we used to call hybrid bonding. I'm not a big fan of Foveros Omni, Foveros Direct, because they're arguably different. Everybody calls them different technologies. It's only Intel that calls them the same. So looking at 1 trillion transistors per package in the future. So now we have Meteor Lake, which is this slide. So Meteor Lake has 5 tiles. So just so you know, base tile is interposer. That's all it is. Then everything else is connected through Foveros. It's 2.5D with Foveros. Can scale each in multiple dimensions. Core count, node scalability, cache scalability. So SOT tile has display engines. Can somebody ask in the Q&A what the heck is on the I/O extender tile? Is it an FPGA? Does it just mean it has configurable IP and can change product to product? So Foveros in MTL is 36 micron. Backside metallization over all chiplets and solder TIM. Yeah, PCH replacement, but that diagram was nothing. So, okay, so here are the voltage islands. This is the slide that I've got up right now. So where it says die to die, ignore that. They're in the wrong place. There's nothing EMIB here. Foveros works at 2 gigahertz, 0.5 to 0.3 petajoules per bit. They didn't keep the same number of significant figures. Who wrote these slides? Come on. Okay. Graphics to SoC. 2K width. Uses ICXL, which is CXL without the phi. Now we're on this slide, just so I'm keeping up as well. SoC to IOE, 1K width, IOSF, 4 times DisplayPort. So yeah, with the thermal slide on, that's just showing how they had a much lower turbo when they started the project, and now they've made discoveries. So but now they're talking about capacitors on base tile, 500 caps on base tile. Okay, this is the result. Yeah. If they put it like that, then you're right. That looks like it's just a chipset. The I/O tile is just the chipset. And to answer to your 2K width, what units? It doesn't say. It just says main bandwidth approximately 2K. So, to your answer about Katamari, my cat is called Katamari. Or cat. For short. Okay. So, trade-off monolithic versus disaggregation. They're showing a few graphs here, basically showing what they had to do to optimize it for the penalties. So, I think, yeah, this is the next slide they're showing. This is if you use different transistors, whether you're using the 6 VTs or the 8 VTs, different versions of Intel 4 libraries to get frequency. Meteor on Intel 4, Arrow on 20A, Luna on Intel Next. So Meteor Lake Mobile is booted and in the lab, and they've got some die shots. So, so it's a 6+8 design in case. So 6P core plus 8E core. The slide I'm showing now is basically how they're planning to scale it from mobile to desktop. I've been told if there's, I said, is there going to be essentially a desktop version? And they said the architecture is scalable, which isn't an answer. So, yeah. They just said it's scalable. Arrow Lake still uses 36 micron Foveros. Lunar Lake uses 25 micron Foveros, which is this slide. Do I have any more? No, that's the final slide. So basically the idea is now they know how tiles and chiplets work, they can put them together. I think the fact that one of the tiles uses integrated version of CXL, that's interesting. I need to find out what IDI is and IOSF is, but perhaps those are the questions that should be in the Slack. What is IDI? What is IOSF? I think that's what I would ask here, alongside with what's on the IO tile. And again, if you were here yesterday, if you go to this link in the chat, is it Hot Chips 22 or Hot Wings 22? Oh, they took it out of the slide deck. I think it's that one. So Q&A time. Let's see what this is about then. They're just going through the speaker bio because they've got to the beginning. I thought they did, but whatever. JL Joe, I fully expect them to go more towards an AMD-like design in the future. It's the only one that makes sense. Really. If you want to scale out, if you want one CPU tile, and if you want more CPUs, you just add more CPU tiles. That's the way you go. You don't just make one CPU tile that's that big, one CPU tile that's that big, one CPU that's that big. So Warren, the Intel 4 and Intel 3 are basically the same for high performance. What Intel 3 brings to the table is all the I/O stuff. Otherwise, if you design a core in Intel 4 and Intel 3 and it's just high performance core, then it's probably going to be the same. So I can't spell soul. We need more details about CXL. So, no. I can answer these questions. I can answer these questions better. I can answer these questions for Intel better than Intel are right now. Last question. And that's it for Intel. On to Mediatek now. Nobody wants to answer questions in this segment. Yes, this guy's name is Eric Bill. Warren, you're right. If the core has CXL, yeah, I'm going to be poking at that. So no, Gustavo, the question that Arnie was trying to ask was that did Intel make a monolithic Meteor Lake, and did it compare to that, and does the interposer make the overall chip bigger? The thing is, the answer to the first question is no. They didn't make a monolithic version. The answer, does the interposer make it bigger, is yes, because it does. Of course it does. So it's a stupid question to ask. I mean, it's almost as if he's never done any research into disaggregated design at all. So we're probably going to be speaking about that for a while. Um, the problem is the people that built Meteor Lake, it feels like they just didn't think about. They were thinking, oh yeah, let's use tiles, but then we're still only using one of each tile. The whole point about chiplet is that if you want to scale, you use more than one tile. So, William, about the package size of consumer set chips, Intel made a big fuss about it with Skylake. So, yeah. Where they made a fuss about, they had to, in order to get the caps in, they had to make a hole in the motherboards. They made a big fuss about that before. Alexi, yeah. This is only a 64-bit, but it's a smartphone, so. Now they're talking about their 1+3+4 CPU design. Use the best CPU at the right point. Yeah. I find it weird that they're presenting the Dimensity 9000, when isn't the 9000 Plus out? And that's, you know, an extra, that's 3.2 gigahertz on the main core and stuff. So yeah, the only phone with the 9000 Plus is the Oppo Find X Pro, I think. I would like to get hold of one so I can do some testing on it, but Mediatek first did a tri-state SoC back in 2016. That was a 2+4+4. Furiza, did you see what phone was it? Instead of having a normal power mode and a performance power mode, it had a normal power mode and a light power mode, which may have just been shifted, but whatevs. The idea is it took 200 to 300 megahertz off of each CPU cluster, but you got a massive increase in battery life. Was it the S22 Ultra? It was something. I saw it on Twitter a few weeks ago. If you search through Andre's Twitter, I think he responded to it. One of his most recent responses, I think, actually. So right now he's just talking about power efficiency curves of reasons why you'd have more than one type of core in a smartphone. I mean, it's an argument that's been presented to death. This isn't a conference for this, but yeah. Samsung Galaxy Z Fold 4 has a low power mode. Yeah, so limits the X2 core to 2.8 gigahertz, the A710 to 2.6, and the A510 to 1.6. So it's a power saving mode. It's a shame it's not the Z Flip 4. But that, so right now it says Geekbench 5 single thread 1278 4400 for the Dimensity 9000. For the Z Fold 4 gets 1156 and 3700, which is less than 10% difference, right? 10% single thread, less than 10% single thread. Yeah, and slightly more than 10% multi-thread. Yeah. So if anybody's wondering what we're looking at, I'll post a link. Yeah. Now they're talking about Dimensity 9000 versus Dimensity 1200, which was the last flagship, so this is real base. Let's see improvements in performance using, yeah. let's look at microarchitecture improvements on CPUs. But a lot of that is, this is all ARM's numbers. I mean, this talk was co-written with ARM. It might as well be ARM architecture through the Dimensity 9000. Cortex X2 is plus 16% over Cortex X1. Improved front end, improved outer order core, improved back end. If you saw the Cortex X2 launch, this is everything that's been presented before. Which is weird, because didn't they just announce the X3? That would have been a much more interesting talk. Yeah, X3 and the A715 was announced end of June. So I guess they couldn't really put it in the agenda unless they just simply said next gen ARM architecture. Yeah, it's because they wanted Mediatek in there as well. It was also Arrow Lake uses 20A. And confirming that it's using 36 micron Foveros rather than 25 is something. So I just want to see what the desktop versions are like, because mobiles are well and good, but mobiles 15 watt, 28 watt, maybe even that was the 45 watt version. Show me how many cores you got in your desktop version. Is it 16? Is it 24? Is it 8 plus 24? Is it, and how is it configured, and how many CPU tiles is that? I mean, if they've got a CPU tile that's both P cores and E cores, why didn't you just make different CPU tiles for P cores and a different CPU tile for E cores, and then you can mix and match? I mean, put 6 or 8 P cores on a P core tile, and put 16 E cores on an E core tile. It's because in mobile they wanted a 6 plus 8. So now their base CPU tile is 6 plus 8. If they want to make a 8 plus 8 or an 8 plus 16 or something bigger, then they have to go and make a brand new tile. The alternative is to reuse that tile. So now you have a 6 plus 8, and in order to expand, you need another 6 plus 8. So then you get a 12 plus 16. And then that's your function of multiplication for cores. I mean, can you imagine a desktop with 12 plus 16 cores? 12 P cores. And the thing is, the P cores and the E cores that are on the same die are obviously fast connected to each other. P cores to the P cores on the other die are slow connected to each other. So the scheduler now has to determine the best way to put a workload on the P cores and the E cores based on what die they are, and then if those dies have the same latency to the cache and the memory. It's not a, they keep saying it's a scalable architecture, but it's only scalable if you make more tiles. The whole point about doing a tiled architecture is reuse and reconfiguration. I should get somebody to highlight some of my hot takes during this stream, because there's been quite a few. The thing is, if you have that many different tiles, it means you've got to manufacture them in the right amounts. If that tile is only used in one configuration, it means it's what they call the right not the right mix, matched set. So a matched set is you've got to have one of everything essentially to build your product. If you have too many of one tile and not enough of another tile, then your number of matched sets is the lowest number out of all of them. The idea is that if you can use a tile across multiple products, then your level of when you need a match set is, it kind of, if you end up with 2x as many tiles on one type of tile, but you use 2 of those per product, then your match set is at a different level. So yeah, it is what it is, and somebody didn't understand tiles. I mean, you could argue that AMD's consumer platform, the only chiplet reuse is either one core chiplet or 2 core chiplets. But that's fine. That gives you differentiation across your product stack. You can't see my hands, but I'm basically going the whole time. So kind of, completely, we're on this slide now anyway. Reason why I picked this slide in the Mediatek is because the lower minimum operating voltage of 0.5 volts. I mean, the graph on the left, it's GPU operating voltage 0.6 volts, then 0.5 volts. You got a graph and it's like that, when really it should be there. And why it's a small V, I have no idea. But let's come on, Mediatek, we've worked together. Let me double check your slides before you present, right? But having just lower minimum operating voltage for idle is good. That's what you want. Save power. That third point, 15% GPU driver saving on CPU by offloading to embedded processor. What embedded processor? If anybody wants to ask a question, the problem is if I do a hot takes video, I'm gonna have to take it from this stream, and I'm only in this like small box. So if I try and the quality of the video is gonna be crap. Who knows? Perhaps I should check my email to make sure I haven't got several from Intel. Nope, no negative emails from Intel. Positive ones. Engineers going, yeah, you understand. No, none of those. Yep. Now we're just talking about the GPU architecture. Do I have any more Marley slides? No. So that's true, Alexi. A new base tile is also required. However, the base tile is the cheapest part of that. I mean, you said it's on 22 FFL, which is now what they're calling 16 or 17. Because that's a passive tile, simply for interconnect and power vias, that's the cheapest part of that. So in the list of things that need doing, it's on the lowest. So you kind of want to use the smallest interposer possible anyway per product. I mean, the whole thing was, if you have tiles and you can mix and match on an interposer, that only works if your tiles are the same size, right? If your CPU tile is the same size as your GPU tile, then maybe you have 3 or 4 CPU tiles and 3 or 4 GPU tiles, and then you can mix and match. Excuse me. Obviously, it depends on the power per tile and how it's distributed, and I guess the base tile also has caps for power. But that's just a scalable thing. Yeah, it's the minimal. APU supports BF16. DRAM bypass to save power bandwidth. So this is ISP to APU to display by passing DRAM, which is, you know, I think we've seen this in APUs for several years. Core config is as expected, 1 plus 3 plus 4. They've done it before. And Samsung 1 plus 3 plus 4. Qualcomm 1 plus 3 plus 4. So this is the last slide, so Q&A. Then on the last talk of the event, Intel Xeon D. Yeah, the ACX Gen 3 being 4+4. I think that was just done for simplicity and the fact they got a higher power budget for that chip. They didn't want to put too many resources into it because Nuvia is going to come in. And that Nuvia core might be the prime core, so 1 plus 3 plus 4. Or it might be Nuvia 1, Nuvia 3, Nuvia 4. Qualcomm's compute strategy is going to be... But I was expecting Qualcomm to have samples by the end of this year and to speak to them at the Tech Summit this year about the Nuvia core. I don't know how much they're going to say because it looks like it's delayed a year or at least 6 months. So we might get a separate event first half of next year about the Nuvia chip. I mean, it'd be great if I can speak to somebody when I'm there at their event mid-November, but yep, Q&A time now. That was a good answer. No, because that's the ARM GPU. Yeah. Okay, last talk of hot chips. So there is a 15-minute closing remarks. So they didn't really probably announce this stuff when it was a few months ago, but if you know what it's about, then I'm not sure you'll get anything new out of this talk, but it is what it is. Going through all the bio for the speaker, for Praveen. I mean, basically reading the LinkedIn page. Come on, everybody's still going strong through to 11 hours. I've just been writing what he's saying, basically. Yeah. Architecture involves compute, memory, PCIe Gen 4, performance, scalability, security, integrated internet. Been It's gone 2:30 a.m. Let's see that slide and this slide. This is the next slide after what he's on now, but yeah. So D27. 20 cores. 4 times DDR4. 8. 4. 8 ports. Ethernet. 32 PCIe 4.0. 24 PCIe 3.0. Got 5.0 there. Gen 3 QAT in line with Ethernet. 100. That's basically, yeah. Yeah, this is basically all the specs for the two families. But they're different sizes. If you follow Xeon D naming, it makes absolutely no sense. I mean, we've had 1200, 1300, then we have a 1500, then we have a 2600. I mean, when it was previous Xeon D, it was easy enough to follow. And we expected it to increase generation on generation, but the update cycles of Xeon D are so different. Basically you have to just keep your ear to the ground and stay in that market to follow them sometimes. So basically you've got your low power 1700 and your high performance 2700. So and you pay more for the extra. Oh, we also had Xeon D 2100. It's using Sunny Cove cores. It's just like the Ice Lake core. But look, here, no, you can't see. So they're comparing 2100 to 2700 and 1700. Now, okay, they both got 7, but one's 2, one's 1, but there's no consistency about gen-on-gen improvements. Whether either CPU follows from the previous gen or whether it's its own new thing, but they're comparing it as if they're the same. Yeah, I didn't choose this slide because I thought it seemed stupid because it's all data we've seen before, but whoever named this stuff was probably called Stephen Fund. That's the problem. Okay, so now they're going to compute architecture. So crypto acceleration, compression, decompression, and then AI. Okay, so AVX 512 and AVX 512 VNI int 8 support. So sometimes Intel puts 512 there, sometimes they don't. It's really weird. IFMA support, it has GFNI, Shani, VAS, and VBMI as well. If you know your Intel instruction sets, these are some of them. They've given, rather than put them all under a singular name like they used to, each one is now different. So if you want to go through instruction support, you've got a list about 35 different add-in instructions different. Some of them may have 2 instructions, some of them may have 200 instructions within each of those lines, but it is what it is. So IFMA is integrate integer fuse multiply add, something like that. It's that sort of stuff. This is Galois field new instructions, SHA new instructions, vector AES, and vector bit manipulation instructions. And these are variable neural network instructions in int8. This is the one that matters most for inference, I think. So, and now we talk about AI at the edge. So, excuse me. I need some colder water. The reason why you would use some of these, because some of these just bundles other instructions together. So instead of pushing 3 instructions through the decoder, you only push 1. And the CPU knows what to do with that one instruction, that it optimizes its cache use, bandwidth, and power. And so if you can use the more overall instruction and it's suitable for what you need, you push that through rather than one of the others. So now we're talking about SGX. You've probably heard about SGX, Intel Software Guarded Sections, many times. It's like Apple enclaves. But every generation, we hear that SGX gets broken and they have to disable it. Because this is like, isn't this like the 3rd or 4th generation now we've had SGX? But all the previous ones have issues. Every time I hear SGX, I was like, what's happened with it now? Might as well call it something new at this point. So, but yeah, this is just, if you know about Apple's secure enclaves, you have a data section where the app and the code just end up there, and it can't be accessed by the operating system or the virtual machine. It's just trusted computing. TSX is a bit different because transactional memory is hard to implement. Even David Cantor thinks it's hard. So they haven't edited this video properly. So now we're going on to Quick Assist. So Quick Assist works on crypto. That's cryptography, not cryptocurrency. This is just accelerating cryptographic algorithms like SM3, SM4. Probably get Chinese versions that do the elliptical accelerators. Basically means when you have data that comes in that's protected, you can do the cryptographic algorithm on that data as it's coming in, rather than taking it to the CPU, doing it there, then put it in memory. It's called an offload accelerator, quick assist technology. And so if you have a 28 core processor, you don't have 7 or 8 of those cores just dealing with the encrypted traffic. You offload it to something else that has its own power consumption. Quick assist, they used to be a part of the chipset if you bought a specialist chipset, and they also had add-in cards. I think the add-in cards got discontinued very quickly. It's one of those technologies that if you know you need it, then you get it. They talk about it a lot, and I'm not sure if that's because Intel wants more customers to use it, or yeah. Not sure why Intel talks about it so much sometimes. Yeah, I've got a feeling it was made for one particular customer, and so they're still trying to monetize it. But So now we're talking about different models of acceleration and some benchmarks. It's, yeah, not great. Not the most riveting. I'll put in this graph up. This is a few slides on, just showing some of the form factors that these chips go in case you're wondering. It's embedded, it's edge, it's 5G, it's telco, it's rugged. It's meant to be, computing at the edge. You ever see those boxes? Massive, at least in the UK, they're massive green boxes on the side of the street, and you know it's to do with the wireless communications. It's not the ones with all the wires in for your landlines. If you actually see them open inside, it's just racks of servers running hardware like this, and it's managing traffic for the traffic for the area through your cable lines. So if you get on the right day when somebody's trying to do work on it, you'll see it open and you'll see all the servers inside. You'd think it'd be louder. I don't know. They do stuff to minimize sound dampening, and it's designed to work in all weathers and a wide variety of temperatures. So it's probably 70 degrees or whatever. Maybe I should put my hand on one, see how warm it is there. So it's worth doing. I mean, if somebody works in that area in London, perhaps we should do a video about what the heck's inside. Maybe that would be interesting. Intel's obviously not the only one that plays in there. A lot of telcos have some of their own custom hardware. You've got AMD, Xilinx, Lattice. If you've heard of Open RAN or vRAN, the idea that everybody used to do this stuff with custom silicon, now as we're moving forward, it's more of an open platform and you can mix and match solutions. Before this slide that I've shown, they've actually got Intel Xeon D2799. So perhaps somebody can ask for a SKU list. Can we get a SKU list? There are no SKU lists. Though the host is called Morosity. I don't know, 40 CPUs? Oh, that's with hyperthreading. Okay, cores per socket 20. 8 memory channels. Oh, because it's DDR4. Why did it say 8? Why did it say 8 memory channels? If anyone's got the slides and let's look at them, look at the final slide. Literally 4th row from the bottom, it says 8 memory channels. But it's a DDR4 system. Microarchitecture, ICX, Ice Lake, yep. Doesn't actually mention the memory. Running Ubuntu 22, so. I mean, companies don't necessarily talk about their rollout in terms of the hardware they're using because not a lot of people are interested. And I wonder if part of that is because they don't know how to talk about the hardware that's involved, right? Or they can't do the right graphs or the right visuals. With the right story, you can talk about almost anything. So I'm not sure if, or maybe they don't want to. Maybe they don't want eyes on it. They want to keep everything behind the scenes and no, because obfuscation through just not talking about it. Security through silence. That sort of thing. Well, they don't want their competitors to know their solutions. Eh. In a slide they've got now, those who can see, it does say integrated I/O with low-powered die-to-die interface. Die-to-die interface? Is the I/O's a chiplet? That's why. This is a chip plus chipset in a package. So, yeah. They don't say that because they don't want people to know. Or they don't think it's relevant. So they're currently showing the slide that I've got on my stream now. So the one on the left is for indoor use without the chassis. With the chassis, it's now rugged, waterproof, and whatever. You can mount it to a lamppost. The white material is such that RF signals can pass through. So on the right is a Xeon D1700 module. 6.3-inch square. So it's slightly bigger than Mini ITX. And it's powered by PoE. Entire server PoE. And you can do it. Obviously, limit your frequency or whatever, but I'd love to power some of my systems with PoE or equivalents, but I don't want to shove 1,000 watts down my Ethernet. It looks like we're at the last slide of this talk. So if you're still watching, stick around because there's a last 15 minutes end of conference finale. This is usually where they talk about how many people attended during the conference and numbers, and be interesting to see how it's changed over the last few years. But yeah, Q&A time. I think Debjit needs to get close to the microphone. He keeps moving away from it. Can somebody lower his microphone, please? Yep, you keep moving away, Debjit. Why not Gen 5? Because it's nice. Because it's a nice slate core. Flash Photo, you missed an annoying Q&A session from AMD and my rant about Intel's tile portfolio. If you replay it and get the timestamps, let me know. Okay. So now we're into the yeah, end of conference. So Gabriel Southern doing the concluding remarks. So, let's see. So, timestamps for the talks are easy because they're every half hour. It's more the ranty stuff that I go on and the hot takes I'm interested. If you want to access the presentations or replays, apparently now after the conference, at a reduced rate, you can have access to the replays and the slides if you want. And then everything will be publicly available about December. Talking about sponsors. Next year should try and be a sponsor for Hot Chips. This year it was stupidly cheap. It was $2,500 for the lowest sponsorship tier. I should have done that. I never got around to it, unfortunately. That's on me. I have to do some more live streams through the year, see if we can bump up some of the funding to pay for it. So the videos on the channel recently have been, yeah, in terms of view counts. The Threadripper Pro review did well. Everything else has been kind of averaging. So talking about the presenters, it'd be interesting to present a Hot Chips. I don't know what I'd present though. People don't want to hear shit from me. Here's me telling how you get stuff wrong. No, they don't want to hear that. The difficulty of working with the press. Firstly, you have to work with me. That's difficulty number one. I will be the most annoying person you've spoken to. But so 1,700 attendees. Many articles in the press, discussion on Twitter. Speak about my live streams, damn it. So that's less than previous years. I think. First hot chips in 1989 at Stanford. Stay away from the marketing presentations, but what was the keynote? They're showing some pictures of the setup. That's pretty cool. The problem is you're patching people in from Zoom. Maybe you need to not use Zoom. Use something like what's the one that some gadget guy uses? Oh, 70% prefer online, 30% prefer in person. Really? 70% of people prefer online? You don't get anything out of the conference then. Not as much anyway. Come on. Go in person. I think most of the committee want it in person. Yeah, the online locals. So yeah. So there is an attendee survey. I need to check those. Thanks, James. Appreciate it. 20 hours of live stream over 2 days. Gotta be fun.
What's your minimum specification?
And it looks like that is a wrap. Yep, Gabe is finished, and yeah. Whew. What does it say we've been running for now? 11 hours, 8 minutes. This is the first hot chips. I've covered every single talk. Normally, I will skip a few just for my own sanity, but I thought, hey, let's do them all. Clear some of them I weren't interested in. Sorry about that if you were. For this stream, we never broke 100 concurrent viewers. I'm somewhat disappointed, but we've maintained at least about a 50 average. Average view duration, 18 minutes. So I think I tweeted some numbers, but I think that's bimodal. So those of you who have stayed the whole length, if you've stayed 11 hours and the average is under 20 minutes, that means for you stayed, but what, 60 people came in and just logged off straight away, less than a few seconds. Yeah, I mean, it's been getting. I'm pretty sure there's like about 6 or 7 of these talks, I would like to do videos on like the NODAR stuff. Got to do a proper Intel one, the light matter one. Initially, I thought the Juniper one might be worth doing a video on, but maybe not. I need to go back and look at the Slack channel for those of you who are attending a conference, because people aren't going to be responding there anymore, I don't think. So I need to go email some people some questions, especially the Tesla guys, see if I can get access to their event. If you still have access to the Slack, go to the Keynote 2 area, and I've got a comment in there. Please upvote it, because then they might see it. And yeah, that's hot chips for another year. And now I haven't answered any emails in the last 2 days, so I need to go do that as well. Yeah, there's scope for doing a couple of things. I might bring in somebody like Paul Alcorn, see if we can do a quick half hour on hot chips, either pre-recorded or a live stream. It depends whether you want banter or something a bit more, fast-paced. And maybe the overview might be better when I have if I do separate videos out. I don't know, I'm actually traveling in a few days, and I've already got a bunch of stuff that I need to edit, and record, and do everything else. I need a video editor. Though the problem is I live in London and everybody's expensive. Or I don't know how to find one. That may be more appropriate. How do you find people to work for you that aren't people you already know? If you know anybody in the UK or similar looking for video editing work, please let me know. The channel doesn't make... If I paid a video editor per video, I would probably be in the red. And that's okay to a certain extent. Ideally, you'd like it to be self-sufficient. It just depends what the input versus the output is. But I'm willing to try if somebody's willing to do half a dozen videos, or if they've got a rate or how long it takes. I don't know. Video editing for me is weird. The other last week, I edited a 12-minute video in 3 hours. And then in the next 3 hours, I managed to edit 3 minutes of a 30-minute video. So that 30-minute video is coming. It's part of my IBM trip, so I need to get it approved. Yeah, DaVinci was... So I use a program called Filmora Wondershare, and the reason why I use that is because that was the easiest... That was the easiest video editor I found out of all of them, plus it only had a one-off fee to pay for a licensed version, and they've been putting so many updates to it. It's got better over time. So I find it relatively quick and fast for what I do in video editing. It's just you need to sit down and do it. And if you're having a good day, you can blitz through it. If you're not, it takes time moving stuff, and there's been requests for me to film in 4K or in 60 frames per second. You may have noticed I've now got a new lighting setup. I've got a new teleprompter. So if you watch my Apple Right to Repair versus Right to Salvage video, that was all done. That was all written out. That was a 10,000 word written video, I think. And it took about 10 minutes to speak. Yeah. Something like that. Maybe it wasn't I have looked into perhaps doing AI videos. Again, another video I want to do is I've been using OpenAI, so that would be fun. I got some interesting stuff there. I've got on my IBM trip, I play with 2nm wafers. I play with 450mm wafers. I've got 2 small videos there. I need to do a couple of videos with Wendell. I might be filming those soon. I know you guys all like the Wendell collabs, so that should be fun. There's lots coming out, and I've got also companies commissioning me videos. A couple of really interesting companies you may or may not have heard of. Yeah, they're looking to do sponsored videos, but I do have requirements that their stuff must be at least interesting to me so I can present a story. And so I need to do some storyboards for those videos as well. That's going to take a few hours of writing. I haven't sat down to do any proper writing. I get too distracted by Twitter, I think. Twitter and Reddit and Discord. So it's if there is particular videos you guys want to see, ping me on Twitter. Go through the email on the channel about page and ping me what you want to see, because it's one of the main ways I get insight into what videos you want to see. So, oh, and I've also got a video about disaggregated infrastructure over PCIe with a company called Giga.io. I filmed that like 2.5 months ago, and I checked the video when I recorded it to make sure the audio was good and I could do something with it. I just haven't even loaded it into my video editor yet, so just stuff like that needs to be done. And yeah, sorry, bit of a brain dump. Always like a good brain dump. But I'll see who I'll be talking with soon. But yeah, that's it for Hot Chips for the large live streams. So yeah, they're fun, but you do need a dedicated conference. I would be, if I wasn't doing live streams, I would be writing up content. I wouldn't be paying attention to the presentations. I'm a one-man band next year, so I've been speaking with some of the Hot Chips committee. Want to go there in person. What I want to say to them is, look, let me still do my watch party even though I'm present. And and give it two options. One, either we do a watch party like we're doing now. I hopefully get a second host in, and then we can take turns, and then in the breaks do interviews. Or we spend the time at the show doing interviews of the speakers, either after or before they've done their presentations. That way we can get them to speak about what they do. That being said, would that be thrilling content? I don't know. I'll see. It's exciting if you watch the presentation, then have the extended Q&A. If I'm going to be there just doing interviews, I won't have time to watch the presentations, if that makes sense. But the only time to do the interview is while they're there, because then they go off and they don't. Yeah. I mean, if I could do it, it'd be nice to be the host of the show, the host of Hot Chips, but then it wouldn't be freely available on YouTube, and you'd have to pay to access it, which is something else. So, yeah, it's almost as if I need to do a post Hot Chips response, and maybe pivot it to, instead of reacting to it live where you can't see anything, I react to it in December when they make all the videos public. Maybe. I don't know. Judging by the graph they showed that only 30% of people want to be on site during Hot Chips and 70% want to be virtual. It makes me wonder, when they do it on site next year. Previously, before the pandemic, we ended up with like 1,000+ people attending, but then there was no virtual option. If they have a virtual option, are we going to end up with like 250 people attending in person? Yeah, I mean, or who knows? Maybe I'll be so much of an analyst at that point that the companies presenting will be asking me, how do we make this not suck? And I'll be answer the damn questions, or make sure you don't have a monotone voice. Make sure you're not repeating the same thing that everybody else has said. You know, we don't need to know about machine learning. We've already heard 20th, for the 20th time, we know what machine learning is. We know we need to scale. We know we need big chips. We know those chips need to be efficient, and we know we're pushing the power boundaries, and we know we can scale out and get petaops and exaops of power, and maybe there's room for video on quantization. I've been thinking, that's been running about, noodling in my head. Oh, and so I've got a project in the works, which is basically a 12-episode series of a show, and I still need to write the scripts for those because I need to film those soon with my co-host and edit them. Lots of things going on. I need to prioritize. Maybe I need to drop some stuff. So I know you guys want to see lots of hot chips post. I'm gonna have to see how much sleep I need. So again, let me know what you want to see, because then that helps prioritize. And yeah, okay, it's now 3:20 a.m. I'm gonna call it a night. This room is actually quite warm. It hasn't had the airflow I expected it to have, so hope you all enjoyed, and I'll see if I can find where all my hot takes are. Actually, while everybody's here, let me put a link to the notes, because I know some people want the notes. Copy link. Okay. Let me just check that works on my side. Yeah, so these are the day 2 notes. If you guys want them. 82 pages this time. Actually, let's just take all the white space. 80 pages. Yesterday, 59, 50, 56, 59 pages. Today, 80 pages. So the notes are as is. If you don't understand them, sorry about that. That's just me. But yeah, enjoy over 100 pages of notes. Yes, don't stay. But with that, I will love you and leave you and say something like good night, good morning. Take care.